Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly, let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible, visible to every one of you. Welcome back, people, welcome back, welcome back, welcome back. Welcome back. Just a second, let me fix your chats here. And with that, we shall be starting the session. So, am I perfectly audible, visible, people? Quickly, let me know in the chats. Good evening, people. Good evening, good evening. Good evening, good evening. Just give me a second, and we shall be starting. Just give me a second, and we shall be starting. All right. So quickly, people, let me know in the chats with some fire emojis if all of you are super duper excited about this particular session. The session from which you are surely going to get some, as you saw the thumbnail, 40 plus guaranteed questions directly or indirectly. Yeah? So already, my dear students, already. Well, by the way, this is going to be the combined session. Combined session means this session will be taken by two teachers. First, it's going to be me, followed by your HSP sir, right? Okay? So it's a combined session. It will take almost like 7 to 8 hours, I believe, right, to complete every single thing. Okay? So all of you are ready for that? All of you are ready for that? Let me know in the chats. Let me know in the chats. As you would have seen the thumbnail, my dear students, it is mentioned your entire chemistry in one single session. That is this particular session. Your entire chemistry. Physical, organic, as well as inorganic. We have included all the chapters here in this particular session. Okay? So I just want to know whether you guys are going to be with me till the end or not. Let me know once in the chats. Let me know once in the chats, my dear students. Everyone. And people, again, I'm repeating the same thing. From this particular session, almost 40 questions directly, indirectly will be asked in your upcoming NEET examination. Because all the questions we have handpicked based on our experience. All the questions we have handpicked based on our experience. Perfect. And at the same time, the PDF of this particular session I shall be sharing on my Telegram. If you are not the part of the Telegram yet, be the part of the Telegram channel. The name of the Telegram channel is, let me tell you that is WASSIM BHAT Chemistry Official. This is the name of the Telegram channel on which I shall be sharing the handwritten PDF of the today's session. Okay? So people, as you know, I start the session with simple question, and that question is, which part of the country you guys are watching me right now? From which part of the country you guys are watching me right now? I just want to know your states. I just want to know your states first of all. Which part of the country you guys are watching me from? I want to know that first. Let me see from where the majority belongs to. I can see Tamil Nadu, Vijayawada, okay, Kashmir, Karnataka, Andhra Pradesh, Delhi, Kerala, Assam, Pondicherry, again Tamil Nadu, my God. Bihar, Kerala, okay. Pune, Haryana, okay. All right. All right. Meghalaya also. That's great. That's great. That's great. So the majority is from Tamil Nadu. Is that? Tamil Nadu and Andhra. And Kashmir. All right, people. All right. All right. Okay. Okay. Got it. Got it. Got it. I got it. Majority is from Tamil Nadu, Andhra. That's amazing. That's wonderful. That's wonderful. And at the same time, are you guys following the another series which we have started? That, I mean, these many marks in 10 minutes, 20 marks in 15 minutes, 40 marks in 10 minutes, which I posted in the morning today. Are you following that series as well? Yes or no in the chats? Please and please do follow that particular series as well. Because that's a very crisp series which will save a lot of time of yours. Okay? Please and please follow that. That's going to save a lot of time of yours. Perfect, perfect, perfect. Perfect. All right. So should we start the session then? Again, I would want some fire emojis in the chats. Let me see how excited you guys are for this particular session. Let me see how excited you guys are for this particular session. Quick, quick, quick. I would want some fire emojis in the chats. I want the chats to be lighten up. Perfect, people. Perfect. Perfect. Amazing. All right. So let me tell you what we are exactly going to do in this particular session. My dear students, from every chapter of your chemistry, from every single chapter of your chemistry, there are almost some, I would say 15 to 20 problem patterns which are asked, okay, from every single chapter. Let's talk about mole concept. In the mole concept, there will be almost like 15 to 20 question patterns which will be asked. In the Redox reaction also, 15 to 20 patterns of the questions which will be asked. Similarly, when it comes to your GOC, again, different types of question patterns which will be asked. And in this particular session, chapter-wise, we shall be covering all those problem patterns over here. And my dear students, again, I'm telling you, if you are following this particular session till the end, let me tell you, we are first of all going to cover all the problem patterns of every single chapter in detail. Okay, and you can expect questions directly or indirectly from this particular session. That's my promise to you. But you need to follow me till the end. Okay, and right after I finish, right after me, HSP sir is going to come with some of the chapters of chemistry as well, because it will not be possible for me to complete the entire chemistry. So we have divided the chapters, me and HSP sir. So first I'll come, and right after me, once I'm done, after that your HSP sir is going to join in as well. Okay. Perfect. Are you guys ready with your pen and paper then? Are you guys ready with your pen and paper? Everybody. Are you guys ready with your pen and paper? Yes or no? Are you guys ready with your pen and paper? Yes or no? Quick. Quick, people. All right then. All right, all right. Perfect, perfect, perfect. So, my dear students, I shall be starting as per the NCERT sequence. I shall be starting as per the NCERT sequence. So, we shall be starting with the chapter mole concept. Mole concept chapter. Let's first of all get to know what kind of problem patterns, what kind of questions can be asked from the chapter mole concept. Okay. So, people, get ready with the first question, which is on your screen. The first question is simply, one atomic mass unit is equal to. One atomic mass unit is equal to. My dear students, one statement which I would want you guys to remember. From that statement, anything can be asked. Let me tell you, 1 AMU, which is also what you call as 1U. You call it as 1D as well. And it is defined as 1/12 of the mass of carbon-12 atom. 1/12 of the mass of carbon-12 atom. And the value of this 1 AMU in grams is equal to 1.66 into 10 raised power minus 24 grams. In terms of Avogadro's number, it is written as 1 by Na grams. So anything can be asked out of this particular statement. As you can see the question, one atomic mass unit in terms of grams is nothing but 1.66 into 10 raised power minus 24 grams. I want the chats to be continuously running. I want you guys to solve the questions with me. Okay? I want you guys to solve the questions with me, people. All right? So this was our first and the basic question from the chapter mole concept. My dear students, look at one more question. These sort of questions are also asked. And the question is the number of atoms in 0.1 moles of a triatomic gas. Triatomic gas like ozone. Ozone is a triatomic gas. Okay? As per the question, we are given with 0.1 moles of ozone. As per the question, we are given with 0.1 moles of ozone. So if I ask you, how many molecules of ozone will be there? How many molecules of ozone will be there? Moles multiplied by Avogadro's number. So these many molecules of ozone we have. Right? As simple as that. Now, my dear students, one ozone molecule contains how many atoms? It contains 3 atoms. And if one ozone molecule contains 3 atoms, therefore 0.1 Na molecules will be containing 3 multiplied by 0.1 Na. The value comes out to be 0.3 Na atoms. Right? And over here, you can put the value of Avogadro's number, which is 6.022 into 10 raised power 23. So these many atoms are basically present. These many atoms are basically present in 0.1 moles of the triatomic gas like ozone. Am I clear with this? Now it's just a matter of calculation, right? 6 3s is going to be 18. So it's going to come as 1.8 into 10 raised power 23. Is there any option like this? 1.8 into 10 raised power 23? Yes, it's option B, which is going to be the correct answer of this particular question. Right? So this is how you're going to approach to this sort of a question, right? Whenever atoms are asked. Perfect. Now, people, moving on to one more question. What is this one more question? Have a look. Have a look carefully. What is this one more question? Have a look carefully. What is this one more question? The question says one atom of element X. You have got an element X and one atom of X has the mass of 6.6 into 10 raised power minus 23 grams. The number of moles of atoms present in 20 kg. We have to calculate the number of moles present in 20 kg of X, right? So basically we are given with 20 kg of X. 20 kg of X means 20,000 grams of X. We have to calculate number of moles present in 20,000 grams of X. And you know, number of moles is nothing but it is given mass divided by the molar mass. Now, my dear students, how do we calculate the molar mass of X here? How do we calculate molar mass of X? So, remember this particular thing. Molar mass of X. That means mass of 1 mole of X. That means mass of 6.022 into 10 raised power 23 atoms of X will be equal to mass of 1 atom of X. Mass of 1 atom of X multiplied by Avogadro's number. So this term cancels out. And this value comes out to be approximately 40 grams. So what is 40 grams here? It is the molar mass of X. My dear students, given mass divided by molar mass. And you got to know this molar mass of X is 40, right? If the molar mass of X is 40, it's going to be 500. So you can say your 20 kg of X contains basically 500 moles of X. Okay? I hope this is clear to everyone. So the correct answer of this particular question is going to be option D. These sort of questions are also asked, people, and do remember this particular question as well. I believe it's clear to everyone. Okay? I believe this is clear to everyone. I'm moving on to one more question. Look at this particular question carefully. Number of atoms of helium in 100 U. 100 U means 100 AMU. So you have to check 100 AMU of helium contains how many atoms? 100 AMU of helium contains how many atoms? How do you check it? My dear students, it's pretty much simple. Since what is the atomic mass of helium? Atomic mass of helium is 4 AMU. So can I say 4 AMU is basically the mass of one atom of helium? Absolutely. If 4 AMU is the mass of one atom of helium, therefore 1 AMU will be the mass of 1 by 4 atoms of helium. Right? 1 AMU will be the mass of 1 by 4 atoms of helium. How many AMU are we given with? 100 AMU. So I can say 100 AMU will be the mass of 1 by 4 into 100, which comes out to be 25 atoms. So basically 100 AMU means the mass of 25 atoms of helium, right? 100 AMU means the mass of 25 atoms of helium. I believe this is again super clear to everyone. Right? Perfect, my dear students. Now moving on to one more question. Look at this particular question as well, right? These questions, they confused you in the examination hall, right? The number of gram molecules. Gram molecules means moles. Gram molecules means moles. So the number of moles of oxygen. Since I have mentioned gram molecules, so I'm going to take oxygen in molecular form. The number of moles of O2 in 6.02 into 10 raised power 24 carbon monoxide molecules. So first of all, if I ask you how many carbon monoxide molecules do we have? How many moles of carbon monoxide we have? My dear students, number of moles of carbon monoxide will be given number of molecules divided by Avogadro's number. So this term cancels. So this value comes out to be 10. So basically, we are given with 10 moles of carbon monoxide. We are given with 10 moles of carbon monoxide. Now, my dear students, if I ask you, in 1 mole of carbon monoxide, 1 mole of carbon monoxide contains how many moles of O2? Be careful with this. First of all, 1 mole of carbon monoxide contains 1 mole of O, but it contains 0.5 moles of O2. 1 mole of carbon monoxide contains 0.5 moles of O2. And if 1 mole carbon monoxide contains 0.5 moles of O2, therefore I would say 10 moles of carbon monoxide will contain 0.5 into 10. That comes out to be 5 moles of O2. And this is something which I was supposed to calculate. So these are basically the moles of O. These are basically the moles of O2 which are present in 10 moles of carbon monoxide. This is something which I was supposed to calculate. 5 moles of O2 means 5 gram molecules of O2. Am I clear with this? Am I clear with this, people? Quickly let me know in the chats. I hope you got to know how do we solve this sort of a question. This is again a frequently asked question, people. Look at this question as well. If you look at the question says 3.011 into 10 raised power 22 atoms of element weighs 1.15 grams. Okay. The atomic mass of the element is. So people, how do we approach to this question? In the question, they have mentioned that 3.011 into 10 raised power 22 atoms have got the mass of 1.15 grams. Therefore, what would be the mass of one atom? What would be the mass of one atom of element? It would be 1.15 divided by 3.011 into 10 raised power 22 grams. This would be the mass of one atom. If this is the mass of one atom, what would be the mass of 6.022 into 10 raised power 23 atoms? I would say the mass of these many atoms is going to be 1.15 divided by 3.011 into 10 raised power 22 multiplied by Avogadro's number, which is 6.022 into 10 raised power 23 grams, right? So this is 1, this is going to be 2, this is 1, this is going to be 10. So 20 multiplied by 1.15. 20 multiplied by 1.15 will approximately come out to be 23 grams. So I would say the mass of 6.022 into 10 raised power 23 atoms, which is basically the mass of 1 mole of X. So 1 mole of X has got the mass of 23 grams, right? 1 mole of X has got the mass of 23 grams. So this is basically the molar mass of X. And if molar mass of X is 23 grams, therefore atomic mass of X will be 23 AMU. Therefore it will be 23 AMU. I believe this is also clear to everyone. Okay. This sort of a question is again asked, people, and you have to be careful with these sort of questions while doing the calculation. I hope I am clear with this. One simple question which is going to boost up your confidence for sure. Tell me the answer of this question. I'm not going to solve this. You are going to solve this. Quickly, my dear students. Quickly, let me know in the chats, everyone. Number of moles in 11.2 liters of carbon dioxide. We have to calculate number of moles in 11.2 liters of carbon dioxide. Quickly, tell me, what is the answer of this? Given volume divided by 22.4. So 11.2 divided by 22.4. The value comes out to be 0.5. Right? A simple confidence booster. And sometimes you get these sort of questions as well. Okay. Look at the next one. Look at the next one. Be very quick in the chats. Let the molar mass of an element is A grams. What does that mean? Molar mass of an element is equal to A grams. The mass of 10 atoms of element in AMU. My dear students, molar mass of the element is equal to how much? Is equal to A grams. Molar mass of the element is equal to A grams. That means atomic mass of the element is equal to A AMU. You just need to change the units, right? This is the atomic mass of element. What does that mean? That means the mass of one atom. That means the mass of one atom of X is how much? It is A AMU. Now people, if the mass of one atom of X is A, therefore the mass of 10 atoms. Therefore the mass of 10 atoms of X will be 10 times A AMU. Perfect. This is the mass of 10 atoms of A in AMU. That is something which I was supposed to calculate. So the answer of this question is simply going to be 10A. I hope you got to know how do we approach, how do we tackle this sort of a question as well. Okay. Next question, my dear students, which is on your screen. Next question, which is on your screen. You have got a gaseous mixture. You have got a mixture containing how many gases? It's not a gaseous mixture. You have got a mixture containing aluminium, magnesium, and 4.6 grams of ethyl alcohol, C2H5OH. So mixture contains aluminium, magnesium, and ethyl alcohol. How many grams of aluminium are there? 5.4 grams. How many grams of magnesium are there? 1.2 grams. How many grams of ethyl alcohol are there? 4.6 grams. What do we have to calculate? The ratio of their moles. We have to calculate the ratio of their moles. My dear students, first of all, how many moles of aluminium are there in the container? Mass of aluminium divided by molar mass. Mass of magnesium divided by molar mass. Mass of ethyl alcohol divided by molar mass. Divided by molar mass, right? So this particular value will come out to be 0.2, right? Perfect. I hope I'm clear. This particular value comes out to be 0.05. This particular value comes out to be 0.1. Okay. So these are basically the moles of each thing which we have calculated. Now, my dear students, we have to get the ratio of these moles. First of all, which one is the least number among the three? The least number is 0.05. I'm going to divide everyone by 0.05. Divide this by 0.05. Divide this by 0.05. Divide this by 0.05. This particular value comes out to be 4. This particular value comes out to be 1. And this particular value comes out to be 2. So 4:1:2 is going to be the ratio of the moles of these three substances which I was supposed to calculate. Am I clear with this? Am I clear with this, my dear students? Everyone in the chats? Everyone in the chats quickly. Everyone in the chats. One more type of question which is asked. Let's have a look on this particular question. You have got an element that is iron. Iron has got how many isotopes? Iron has got 3 isotopes. One is Fe54, one is Fe56, and one is Fe57. So these are the 3 isotopes of iron. My dear students, as per the question, the percentage abundance of the first isotope is 5%. Second isotope, it is 90%. Third isotope, it's again 5%. What do we have to calculate? We have to calculate the average atomic mass of iron. We have to calculate average atomic mass of iron. Right? Now, my dear students, what you need to do here, first of all, how do we calculate average atomic mass? There is a result, M1A plus M2B plus M3C divided by 100. This is the result to calculate average atomic mass. This is the result to calculate average atomic mass. So first of all, the percentage abundances we represent with A, B, and C. Right? This is the value of your M1, this is the value of your M2, and this is the value of your M3. Now, my dear students, put all the values in the expression. So M1 multiplied by A, that is 54 multiplied by 5, plus M2 multiplied by B, that is 56 multiplied by 90, plus M3 multiplied by C, that is 57 multiplied by 5, divided by A plus B plus C, that's 100. When you solve this question, the value comes out to be 55.95 AMU. So this is basically nothing but the average atomic mass of iron, which I was supposed to calculate. Am I clear with this as well? Quickly. Don't take a lot of time. Quickly, my dear students. Quickly in the chats. In this session, physical, inorganic, as well as organic will be covered. Just wait. We are going step by step. This is chapter number 1. Then comes chapter number 2, chapter number 3. That's how we are going to proceed in the today's session. Don't worry. Everything will be covered. My dear students, the percentage of oxygen in CH2O. So basically, we have to calculate mass percentage of oxygen. Mass percentage of oxygen. Okay? Mass percentage of oxygen. First of all, how do we calculate mass percentage of element in a compound? How do we calculate mass percentage of an element in a compound? That's equal to molar mass of the element, molar mass of oxygen, 16, multiplied by. In 1 mole compound, how many moles of O are there? In 1 mole compound, there is 1 mole O, divided by molar mass of the entire compound, which is 16 plus 2 is 18, 18 plus 12 is 30. So 30 grams is the molar mass of the compound, multiplied by 100. Just solve this, get the mass percentage, that's it. Right? Molar mass of the element multiplied by 1, because 1 mole compound contains 1 mole O, divided by molar mass of the compound multiplied by 100. So this is how you can calculate the mass percentage of what? This is how you are going to calculate mass percentage of oxygen in your given compound over here. My dear students, look at one more question. I believe you would have solved this question because it's a common question. It's a common question given in different your books. What volume of O2 measured at 0 degree and 1 atm is needed to burn completely 1 liter of propane? What is the formula for propane? C3H8. You are doing its combustion. When you are doing its combustion, it will give us carbon dioxide and water. It will give us carbon dioxide and water. So first of all, you just need to balance this reaction. When you balance this, this becomes 3 times. This becomes 4 times. This becomes 5 times. And here it's 1. From the stoichiometry of the reaction, I can say, in order to do the combustion of 1 liter propane, 5 liters of O2 are required. In order to do the combustion of 1 liter of propane, I would say 5 liters of O2 are required. So the answer of this particular question is simply 5 liters. The question was saying that how many liters of O2 are required for the combustion of 1 liter propane, and we got to know from the stoichiometry itself that 5 liters of O2 are required for the combustion of 1 liter of your propane. Right? I hope you are remembering how I'm solving the questions with all of you. I hope you are remembering the approach of these questions over here. Now, my dear students, look at one more question. The question based on your limiting reagent. Try to understand what exactly I'll be doing. My dear students, I'm giving you the reaction. Let me write the reaction again. Zinc plus 2 times HCl. It gives me ZnCl2. And with that, I've got H2. This is a balanced chemical equation that's given to me. At time t is equal to 0, how many moles of zinc are given to me? 0.3. How many moles of HCl are given to me? 0.52. So initially, this will be 0. This will be 0. Now, in the question, they're asking me how many moles of H2 are produced. How many moles of H2 gas are produced, right? So first of all, I'll identify which one is the limiting reagent among the two. How do you check the limiting reagent? Given moles divided by the stoichiometric coefficients. So 0.3 divided by 1. This is 0.52 divided by 2. This value comes out to be 0.26. Now, which value is coming out to be lesser? 0.26 is coming out to be lesser. The one that gets the lesser value is your limiting reagent. So if HCl is the limiting reagent, it would have got completely consumed in the reaction. And entire product formation will be decided by the limiting reagent. Entire product formation is decided by the limiting reagent. Now have a look. The stoichiometric coefficient here is 2. Here it's 1. I can say simply 2 moles of HCl. 2 moles of your limiting reagent produces 1 mole of H2. And people, if 2 moles of HCl produces 1 mole of H2, I can say 1 mole of HCl produces 1 by 2 moles of H2. Therefore, 0.52 moles of HCl will be producing 1 by 2 multiplied by 0.52. The value comes out to be 0.26 moles of H2. So these are the moles of H2 which are produced over here. These are the moles of H2 which are produced over here. I hope you got to know how do we solve this question. I hope you got to know how to solve this particular question. I hope I'm clear with this. And my dear students, if we are clear with this, let's have a look on one more question. Let's have a look on one more question. Methylation of 10 grams of benzene. Methylation of 10 grams of benzene gives 9.2 grams of toluene. Calculate the percentage yield. Calculate the percentage yield of the reaction. So first of all, do you guys remember how do we calculate percentage yield? Do you guys remember how do we calculate percentage yield? My dear students, there is a simple formula to calculate percentage yield. What is that? It is experimental amount. That is experimental amount divided by the expected amount. Expected amount multiplied by 100. Experimental amount divided by expected amount multiplied by 100. Okay. Perfect. So have a look exactly. As per the question, we are starting with benzene C6H6. We are doing its methylation. We are doing its methylation. So what do we get? We get C6H5CH3, right? When we do the methylation of benzene, this is what we get over here. We get toluene over here. And as per the question is concerned, the question is saying 10 grams of benzene on methylation gives 9.2 grams of toluene. So whatever data is given to us in the question, that's always experimentally verified data. That's always experimentally verified data. So I can say it is observed in the lab that when 10 grams of benzene undergoes methylation, 9.2 grams of toluene are produced. So this is my experimental amount. This has been observed experimentally. Now what do I need? I need expected amount. How do we get the expected amount? Expected amount is calculated with the help of stoichiometry. Remember that. Expected amount is calculated with the help of stoichiometry. Now people tell me one thing. What is the mass of 1 mole of benzene? That is 78 grams. So I can say 78 grams of benzene should produce. What is the mass of 1 mole toluene? Let's check it out. C6 means 12 into 6, 72. 8 hydrogen means 8. And this is carbon, 12. So 8 to 10, 10 to 12, 7, 1, 8, 9. So 92. 92 grams is the molar mass of this toluene. 92 grams is the molar mass of toluene. That means the mass of 1 mole of toluene is what? It is 92 grams. So I can say as per stoichiometry, 78 grams of benzene should produce 92 grams of toluene. So 1 gram of benzene should produce 92 divided by 78 grams of toluene. Right? 1 gram of benzene should produce 92 divided by 78 grams of toluene. Therefore, as per the question, 10 grams of benzene should produce 92 divided by 78 multiplied by 10 grams of toluene. So my dear students, this is my expected amount of toluene which should get produced. This is the expected amount. Since we have used stoichiometry, and stoichiometry always gives us the expected amount. Now people, just calculate the percentage yield. Percentage yield is equal to experimental amount 9.2 divided by expected amount 92 divided by 78 multiplied by 10 and multiplied by 100 over here. Right? I hope this is clear. So this is 1, this is 10 times. 10 into 10 is 100. So this 100 and this 100 gets cancelled out. 78 comes up. So percentage yield of the reaction is nothing but 78%. So 78% is the yield of the reaction. I hope this sort of a question you would be able to solve from now onwards easily if it is asked. Yes? Let me know once in the chats, people, quick. Let me know once in the chats, quick, everyone. Quickly. Everyone. Is everything clear till here? Amazing. Moving on. Look at this sort of a question. What do you think? Sir, because of you, I was able to crack NEET. Thank you for your classes. That's amazing. That's great. Good luck for your future. All right. as far as this particular question is concerned, 0.44 grams of a colorless oxide, 0.44 grams of a colorless oxide of nitrogen occupies 224 ml at STP. The molecular formula is, people, it's a pretty simple question. As far as the question, 224 ml of your gas, 224 ml of the gas has got the mass of 0.44 grams. This is given in the question. Okay, 224 ml of the gas has the mass of 0.44 grams. Therefore, 1 ml of the gas, 1 ml of the gas has the mass of 0.44 divided by 224 grams. Clear? My dear students, 22400 ml, 22400 ml of the gas, right, which is basically 1 mole of the gas at STP, will have the mass of 0.44 divided by 224 multiplied by 22400 grams. So this is 1, this is 100, the value comes out to be 44 grams. So what is this 44 grams? 44 grams is the mass of 22400 ml of the gas, which means it is the mass of 1 mole of the gas, which means it is the mass of 1 mole of the gas. And the mass of 1 mole of the gas is what you call as molar mass. So basically we have calculated molar mass of the gas, right? Basically we have calculated molar mass of the gas. If you calculated molar mass of the gas, what would be its molecular mass? I would say its molecular mass, would be not 44 grams, it would be 44 AMU, or you can say 44 U. Now, which of these following gases have got the molecular mass of 44? Just check it out. Which of these gases have got the molecular mass of 44? Let me check it out. Oxygen has got 16. 2 nitrogen will have 14, 28. So 28 plus 16 comes out to be 44, right? So 44 AMU. This is basically the gas whose molecular mass is 44 AMU. I believe this is clear to everyone. And if it is clear, let me know once in the chats. And people, let me tell you, these sort of questions are asked in your examination. So be careful with these questions. Be careful with these questions. Be careful with these questions. Okay? Right? Okay. One more question. I do not want you guys to use your brain in this question. Use one direct result, because a question is asked in which molarity will be given, molality will be to be calculated, or molality is given, molarity is to be calculated. So do one thing, remember one direct result from now onwards, right? Do not use your brain in this question, because it will take a lot of time if you use the definition and stuff and try to solve the question. Just remember one simple result. Molality is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. This is the result which you have to remember. And this result connects your molality with molarity. Now, as per the question, we have got an aqueous solution whose density is given, molality is given. We have to calculate molarity. We have to calculate capital M. So molality is given to me as 3.3 is equal to 1000 multiplied by capital M divided by 1000 multiplied by density of solution. How much is the density of solution? 1.2 minus M multiplied by, what is the molar mass of solute? Molar mass of KCl is nothing but 74.5. Do you see we got one equation which just contains one variable, and that variable is capital M. So you can easily solve this and get the value of capital M. Right? It is just a matter of calculation. Do the cross multiplication and stuff. Get the value of molarity, capital M, which I was supposed to calculate. And when you solve this, the answer is going to be option A. Okay? The answer is going to be option A. This question, I believe you would have already solved. This question, I believe you would have already solved. Is that? Have you ever solved this question? Because it's a very common question. It's a very common question. My dear students, the question is, if 3.01 into 10 raised power 20 molecules are removed from 98 milligrams of H2SO4, then calculate the number of moles of H2SO4 left. Number of moles of H2SO4 left. Number of moles of H2SO4 left would be equal to. So first of all, what mass of H2SO4 we had? We had 98 into 10 raised power minus 3 grams. So these many grams of H2SO4 we had. These many grams of H2SO4 we had. So do one thing. Divide the given mass with its molar mass. So what do I get? So these are basically the moles. These are the moles of H2SO4 which we had. These are the moles of H2SO4 which we had. Now from these moles of H2SO4, how many moles of H2SO4 are we removing? We are removing these many molecules. How many molecules? 3.01 into 10 raised power 20 molecules we are removing. So I'm dividing this with Avogadro's number. 6 into 10 raised power 23. So this becomes, these are the moles now. These are the moles of H2SO4 which are removed. These are the moles of H2SO4 we are removed. So initially these many moles of H2SO4 we had. These many moles of H2SO4 are being removed, right? Subtract them and get the moles of H2SO4 left. Question purely based on calculation, nothing else. Question purely based on calculation, nothing else. Am I clear with this? Quickly, people. I hope you would be in a position to solve this sort of a question from now onwards. And when you solve this, the answer is going to be simply, the answer is simply going to be 0.5. Okay. Now, people, one more question. One more question. Your favorite question. Question based on your molecular empirical formula. Question based on your molecular empirical formula. Right? It's a short question, people, which is asked almost every year. Now, how do we solve this? We have got a compound containing two elements. Elements are X and Y. We have got a compound containing two elements, X and Y. Now, as per the question, what is the mass percentage? What is the mass percentage of X? Mass percentage of X is 50%. Therefore, what would be the mass percentage of Y? It will be also 50%. Atomic mass of X and Y is given. Atomic mass of X is 10 AMU. Atomic mass of Y is 20 AMU. Perfect. Whenever you see this sort of a question and you are supposed to calculate empirical formula, how do we do it? First of all, you have to calculate atomic ratio. What is atomic ratio? Given percentage divided by atomic mass. So 50 divided by 10. This is also 50 divided by 20. This value comes out to be 5. This value comes out to be 2.5. Right? So we got the atomic ratio. After getting the atomic ratio, what do I need? I need least atomic ratio. How do you get the least atomic ratio? Tell me which term is smaller among these two. 2.5 is smaller among these two. So I'll be dividing both these terms by 2.5. So divide by 2.5. Divide this term also by 2.5. So this is 2, this is 1. So this is my simplest whole number ratio, 2:1. So we have got the element X is X and Y, and simplest whole number ratio we got to know as 2:1. So as per this, the empirical formula of the compound has to be X2Y1. So is any option like that X2Y1? Yes, it's option B. That's going to be the correct answer of this particular question. So let me know in the chats if it's clear. Let me know in the chats if it is clear. Now, are you all ready for redox reaction? Are you all ready for redox reaction? Are you all ready for redox reaction? Yeah? Are you all ready for redox? But before starting redox, let's take a break for 5 to 6 minutes, okay? Let's take a break for 5 to 6 minutes. Because I don't want my throat to be dead. I will just have a cup of tea so that my throat is recovered. Because it's already over. It's already gone. Okay? Let's take a break for... be back at 9 p.m. After every chapter, we'll be taking like 5 to 7 minute break. After every chapter, we'll be taking 5 to 7 minute break. But I would want every one of you to be back in these 9 minutes. The time is right now 8:52. I want everyone to be back exactly at 9 p.m. So you have got 8 minutes of time. Don't go. Okay? Be here in the chats only. I'm looking at your chats from my phone. I'll see you in just 8 minutes. Is everyone back? Is everyone back? Is everyone back? Let me know in the chats. Quick, 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 people. So ready for the redox reaction now? Ready for the redox? Ready for the redox? Everyone, ready for the redox? Yes, step by step, you guys are closer to victory. Absolutely. That's the kind of mindset which you should have at this point of time. Step by step, you guys are getting closer. All right, people. So let's move on to the first question, which is on your screen, and it's a PYQ. It's a PYQ. It is a PYQ, people. What is the change in the oxidation number of the carbon in the following reaction? Change in the oxidation state of the carbon in the following reaction. Change in the oxidation state of carbon in the following reaction. So, my dear students, let the oxidation state of this carbon is X. Hydrogen is going to show +1 oxidation state. There are 4 hydrogen atoms. Net charge is 0. So, the value of X here will be -4. Let the oxidation state of carbon is X. Chlorine is going to show -1. There are 4 chlorine atoms. Net charge is 0. The value of X will come out to be +4. So, the oxidation state of carbon is changing from -4 to +4. So, -4 to +4 is the correct answer. A very simple basic question, right? A very simple basic question which is asked. One more PYQ I'm giving you, or no? Yeah, one more PYQ I'm giving you. The oxidation state of chromium in CrO6. You should know this as well. First of all, what is the formula? What is the structure of CrO6? If you do not know, remember this then. This is the structure of your CrO6. This is the structure of your CrO6. Now, my dear students, if you talk about this particular single bond between chromium and oxygen is more electronegative, so it will attract the electron pair towards itself, due to which chromium gets +1. Due to this bond, chromium again gets +1. Due to this bond, chromium gets +1. Due to this, +1. Due to this, +1. Due to this, +1. So what is the total charge present on chromium? It is going to be 1, 2, 3, 4, 5, 6. It is +6. So +6 is the oxidation state of chromium in your CrO6. Right? A very simple and basic question, which I believe is clear to everyone. Perfect. Now, my dear students, look at the next one. Look at the next one. It is again a PYQ. I want you guys to solve this question as well. Look at the question carefully. Which of the following reactions are disproportionation reactions? Disproportionation. What happens in disproportionation? In the disproportionation reactions, oxidation state of same element increases as well as decreases simultaneously. Oxidation state of the same element increases as well as decreases simultaneously. Now, my dear students, if you talk about this copper here, it is in +1 oxidation state. This copper here is in +2 oxidation state. This copper is in 0 oxidation state. Okay, so +1 to +2 means increase. +1 to 0 means decrease. So oxidation state of same element is increasing as well as decreasing. So I will say this Cu positive is undergoing disproportionation. Yes, it undergoes disproportionation, right? Look at the next reaction. In the next reaction, you have got MnO4 dinegative, where the oxidation state of manganese will be +6. And finally, you are getting MnO4 negative and you are getting MnO2. You are getting MnO2. What is the oxidation state of manganese here? It is +7. Oxidation state of manganese here +4. So basically +6 to +7. means increase. Plus 6 to plus 4 means decrease. So oxidation state of same element is again increasing as well as decreasing simultaneously. And whenever you have such kind of the compound wherein oxidation state of same element increases as well as decreases simultaneously, we say that particular compound undergoes disproportionation. So again, this is the example of what? Again, this is the example of disproportionation reaction, right? Perfect. Look at the next one, my dear students. Here manganese is in plus 7 oxidation state, right? Here manganese is in plus 6 oxidation state. Here manganese is in plus 4 oxidation state. So plus 7 to plus 6, decrease. Plus 7 to plus 4, again decrease. So it is not undergoing disproportionation. Same goes for the last one. So it's 1 and 2, which is the examples of this disproportionation reaction. I hope this sort of a question is also clear to everyone. One more question, and this question has been asked in AIMS 2016, guys, right? Have a look on this particular question as well. Substances that are oxidized and reduced. Substances that are oxidized and reduced in the following reaction. First of all, talk about the oxidation state of this oxygen. Hydrogen peroxide, it's -1. Here it is -2. So -1 to -2 means decrease in the oxidation state. Decrease in the oxidation state means reduction. So this H2O2 is undergoing reduction. If H2O2 is undergoing reduction, that means this will be undergoing oxidation. This will be undergoing oxidation. So N2H4 is being oxidized, H2O2 is being reduced. So N2H4 and H2O2 is the answer, right? Simple basic question this is. Simple basic question this is. And you should remember these questions properly. My dear students, in this particular reaction, you have got ferrous oxalate, FeC2O4. It is getting converted into Fe tripositive, and with that you have got carbon dioxide as well. Okay? With that you have got carbon dioxide as well. You have to calculate N factor of this ferrous oxalate. You have to calculate N factor of this ferrous oxalate. Try to understand how it's calculated. If you talk about the oxidation state of iron here, it's +2. Oxidation state of carbon here, it's +3. Oxidation state of iron here is +3. Oxidation state of carbon here is +4. So iron is changing its oxidation state from +2 to +3. So increase. Carbon is changing its oxidation state from +3 to +4. Again increase. Whenever you have got a compound wherein oxidation state of more than one element either increases or decreases. Either increases or decreases. How do we calculate its N factor? Its N factor is calculated as N1 plus N2. How do we get N1 and how do we get N2? Have a look. +2 to +3. What is the change? Change in the oxidation state is 1. 1 is the change for 1 atom of iron, and I've got only 1 atom. So N1 value is 1 here. +3 to +4. What is the change? Change in the oxidation state is 1. 1 is the change for 1 carbon. I have 2 carbon atoms. So N2 value is equal to 2. So overall is going to be N1 plus N2. That comes out to be 3. So N factor of ferrous oxalate in this particular reaction is going to be 3. So remember, whenever you have got a compound wherein the oxidation state of more than one element either increases simultaneously or decreases simultaneously, right? Its N factor is going to be N1 plus N2. And I believe you got to know how to calculate N1 and N2 over here. Perfect, people. Look at the similar sort of question so that you get used to these sort of questions. You have got Cu2S, and Cu2S gives copper dye positive, and with that you have got SO2. With that you have got SO2. Now, my dear students, first of all, what is the oxidation state of copper here? +1, sulfur here -2, copper here +2, and sulfur here +4. Sorry. If you look at the oxidation state of copper, it is going from +1 to +2. That means increase. Sulfur -2 to +4, again increase. So oxidation state of more than one element, oxidation state of more than one element is increasing simultaneously. If oxidation state of more than one element increases simultaneously, how do we get its N factor? As I told you a few minutes back, it is N1 plus N2. Now, get the value of N1. +1 to +2, change in the oxidation state is 1. 1 is the change for one atom, but I have 2. So N1 value is equal to 2. -2 to +4. -2 to +4. What is the change? Change is final minus initial. So 4 minus -2, which comes out to be 6. 6 is the change for one atom. I've got one atom, right? So N1, N2 value is 6. So N1 is 2, N2 is 6. 6 plus 2 makes it 8. So N factor of this Cu2S is nothing but 8. Perfectly done. N factor of this Cu2S is nothing but 8. I hope this question is also clear. Now, my dear students, one more important thing which you need to know. One more important thing which you need to know. In this question, I'm supposed to calculate the oxidation state of, I'm supposed to calculate N factor of Br2. How do we calculate n factor of Br2 over here? This is one more good example, and this is asked in the examination. That's the reason why I have come up with this. If you look at the oxidation state of bromine here, it is 0. Oxidation state of bromine here is +5. Oxidation state of bromine here is -1. So 0 to +5 means increase in the oxidation state. 0 to -1 means decrease in the oxidation state. So can I say oxidation state of same element is increasing as well as decreasing simultaneously? So I would say this particular species undergoes disproportionation. And whenever you have got a species undergoing disproportionation, how do you calculate its n factor? Its n factor is nothing but n1, n2 divided by n1 plus n2. n1, n2 divided by n1 plus n2. So I have to get the value of n1. I have to get the value of n2. Have a look. 0 to +5. What is the change? Change in the oxidation state is 5. 5 is the change for one atom, but I have two atoms. So n1 value is 10. 5 2s are 10. 0 to -1. What is the change? 1. 1 is the change for one atom, but I have 2. So n2 value is equal to 2. So it is going to be 10 multiplied by 2 divided by 10 plus 2. The value comes out to be 20 divided by 12, which is 5 divided by 3. So 5 divided by 3 is going to be the n factor of Br2 over here. Now, in the question, they might ask you about the equivalent mass of Br2. Equivalent mass. Equivalent mass is nothing. That is molar mass divided by n factor. So get the molar mass of Br2. Divide that with the n factor. You'll be getting the equivalent mass as well. Okay. Remember this particular question as well, people. Okay. Have an eye on this particular question. I am moving on to one more. If you look at this reaction is asked in 3 different examinations. NEET 2018, AIEEE 2013, JEE Mains 2021. Okay. How do we balance this reaction? Have a look. How do we balance the reaction? My dear students, you have got MnO4 negative plus C2O4 di negative. It gives Mn di positive plus carbon dioxide. We have to balance this reaction in which medium? In acidic medium. See, how do we balance the reaction? Understand properly. Understand properly. First of all, tell me the n factor of this MnO4 negative. Manganese is going from +7 to +2. So n factor is 5. Carbon is going from +3 to +4. Change is 1. 1 is the change for 1. I have 2. So its n factor is 2. So first of all, you need to calculate n factor of the reactants. Once you get the n factor of reactants, just crisscross these n factors. What does that mean? That means make this 2 as the coefficient here. Make this 5 as the coefficient here. Crisscross these n factors. After crisscrossing the n factors, balance all the atoms except hydrogen, oxygen. Balance all the atoms except hydrogen and oxygen. See, 2 manganese here. 5 2s are 10 carbon here. I have balanced all the atoms except hydrogen, oxygen. Now, my dear students, in acidic medium, we balance oxygen first. How many oxygen do we have on the left side? 4 2s are 8 plus 5 4s are 20. So we have got 28 oxygen atoms on left side. On right side, we have got 10 2s are 20. 20 oxygen atoms. On left side, 20 oxygen atoms. On right side, 20 oxygen atoms. Which side is oxygen deficient? Right side is oxygen deficient. How many oxygen deficiencies are there? 8 oxygen deficiencies are there. So just do one thing. Add 8 water molecules on this side, which is oxygen deficient. Add 8 water molecules at that side, which is oxygen deficient. Now, talk about hydrogen. How many hydrogen on this side? 16. How many hydrogen on this side? No. So this side is hydrogen deficient. How many hydrogen deficiencies? 16 hydrogen deficiencies. So add 16 H positive on that side, which is hydrogen deficient. Now this reaction is balanced. You can finally find your option. So first of all, remember the sequence. First of all, get the n factors of reactants, crisscross the n factors, balance all the atoms except hydrogen, oxygen, then balance oxygen by adding water molecules to that side, which is oxygen deficient, then balance hydrogen by adding H positives to that side, which is hydrogen deficient. That's all. Okay. That's all, my dear students. That's all, my dear students. Okay. I believe this is clear. Now, let's move on to one more chapter, that is atomic structure. The questions which I showed you from Redox, these are the frequently asked questions, my dear students, when it comes to the Redox reactions. So have an eye on these sort of questions the most. Okay, and expect one question directly or indirectly from these questions which I showed you for sure, 100%. Okay, perfect. Now, I'm starting with the first question, and I believe this first question will be solved by everyone. So I'm looking at your chats. What do you think about this one? Which of the following is never true for cathode rays? Which of the following is not true for cathode rays? Sir, com proportionation reaction thoda explain kijiye. Reverse of disproportionation reaction is com proportionation. Reverse of disproportionation is com proportionation. That's it. Okay. Tell me the answer of this question, people. This is a simple question, which I believe everyone should solve on its own. I mean, you're not supposed to solve this though. Quick. Yeah. Quick, 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 quick. Quick, quick, everyone. Quick, people. Everyone. Everyone. Cathode rays. Which of the following is incorrect? This is the incorrect statement. Okay, they are not electromagnetic waves. They are not electromagnetic waves. Moving on. Moving on. The value of Planck's constant is given. The speed of light is given. Which value is closest to the wavelength in nanometer of a quantum of light with frequency 6 into 10 raised power 15? Okay. We have to get the wavelength. We have to get the wavelength. My dear students, frequency is given to us. Frequency is given to us. 6 into 10 raised power 15. Second inverse. What do we have to get? Wavelength. You know, frequency is nothing but c divided by lambda. So c divided by lambda is 6 into 10 raised power 15. So I can say lambda is equal to c divided by 6 into 10 raised power 15. Now what is c? C is velocity of light, which is 3 into 10 raised power 17. But this is nanometer. This is nanometer. Nanometer. 1 nanometer is how many meters? Quick. Can you tell me in the chats? 1 nanometer is how many meters? Quick in the chats. Everyone. Ten raised power minus 9. Right? 10 raised power minus 9 meters. Divided by 6 into 10 raised power 15 over here. Perfect. Perfect, guys. So can be solved easily. It's a simple basic question. Oh, just a second. I think we have to calculate in nanometers only. We are not supposed to calculate in meters. Have they asked in nanometers? Which wavelength is closest to the wavelength in nanometer? Sorry, my bad. We have to calculate in nanometers only. Anyways, this will be the wavelength in meters, right? This will be the wavelength in meters. Perfect. You can convert it further again into nanometers. So not a big deal, right? Not a big deal. Not a big deal, my dear students. Look at the next question. Again, a simple question this is. Again, a simple question this is. Calculate the energy in joules corresponding to light of wavelength 45 nanometers. So lambda is equal to 45 nanometers into 10 raised power minus 9 meters. Okay. Our speed of light is given. H is given. We have to calculate the energy. E is equal to, you know, hc divided by lambda. E is equal to hc divided by lambda. H value, you should know 6.6 into 10 raised power minus 34. C value is given to me as 45 into 10 raised power minus 9 divided by lambda value as per the, C value is equal to 3 into 10 raised power 8 meter per second divided by lambda value is 45 into 10 raised power minus 9. Again, a matter of calculation. Get the value of energy in joules over here. Since I've used all the parameters as per SI system, if I've used all the parameters as per SI system, you'll be getting the value of energy as per SI system as well. And energy is nothing. Its units in SI system is joules. All right. Perfect. It's a simple question, guys. Just a question based on the calculation. The energies E1 and E2 of two radiations. We are given with two radiations. Energy of the first radiation is 25 electron volt. Energy of the second radiation is 50 electron volt. Okay. The relation between their wavelengths. We have to get the relation between their wavelengths. Since you know energy is inversely proportional to lambda. You know E is equal to hc by lambda basically. So can I say E1 divided by E2 has to be nothing but lambda 2 divided by lambda 1. Right? So lambda 2 divided by lambda 1 is equal to E1 by E2. E1 is 25. E2 is 50. The value comes out to be 1 by 2. So lambda 2 is to lambda 1 is equal to 1 is to 2. Is equal to 1 is to 2. Okay? Is equal to 1 is to 2. Perfect, guys. Am I clear? Or you can write it like this as well, since the options are given in this format. So you can say 2 times lambda 2 is equal to lambda 1. 2 times lambda 2 is equal to lambda 1. A simple basic question which I believe majority of the students can easily solve. Right? Okay, one theoretical question. Check it out and tell me its answer. One theoretical question. I want answer from everyone. In the photoelectric emission, the energy of the emitted electron is greater than incident photon, same as incident photon, smaller than incident photon. Energy of the emitted electron, my dear students, energy of the emitted electron, it's always less than that of energy of the incident photon. Okay? It is always less than that of energy of incident photon. Simple basic question which I believe you already would be knowing. Okay, tell me the answer of this question as well. Calculate the energy of 100 photons in joules if the wavelength of light is 2000 angstroms. So lambda is equal to 2000. Lambda is equal to 2000 angstroms. How many photons are we given with? 100 photons. We have to calculate energy associated with 100 photons. E is equal to NHC divided by lambda. Everyone would have heard. N value, number of photons, 100. The value of H multiplied by C combinedly I'll be taking as 12400 electron volt angstroms divided by lambda directly taken angstroms, 2000 angstrom. So angstrom cancels out. This double zero cancels. This 0 cancels with this. So it comes out to be 1240 divided by 2, which comes out to be 620 angstrom. 620 energy is going to be in electron volts here, right? Since this is the energy in electron volts, but as per the question I have to get in joules. Remember, 1 electron volt is nothing but 1.6 into 10 raised power minus 19 joules. So just multiply this with 1.6 into 10 raised power minus 19. The answer is going to come in joules. Okay? Perfect. A simple basic question. Whenever lambda is given in angstroms, you can directly take the combined value of H multiplied by C as 12400. Okay? As simple as that. Am I clear? Am I clear, people? Someone is asking a question in the chats. 0.2 moles of KMnO4 can oxidize how many moles of oxalic acid in acidic medium? Let me solve his doubt. Just a second, guys. Just a second. After that, I'll continue. The question is KMnO4. KMnO4 is treated with what? Oxalic acid. H2C2O4. Okay. As per the given scenario, what you are writing, 0.2 moles of KMnO4. So its moles are 2. N factor of KMnO4 in acidic medium is 5. Right? Its moles you have to calculate. N factor of this oxalic acid is going to be how much? See, this KMnO4 is going to convert oxalate ion into the carbon dioxide. So its N factor is simply going to be 2. So use the equivalent concept. N1 multiplied by N factor 1 is equal to N2 multiplied by N factor 2. So N1 is 2 multiplied by 5 is equal to N2 is equal to N2 multiplied by N factor. So 2 gets cancelled. N2 value is equal to 5. So the answer of your question is equal to 5. So basically 2 moles of KMnO4 will oxidize 5 moles of your oxalate ion. I hope I'm clear. The one who gave the question. Okay? The one who gave the question. Perfect. Chalo, I'm moving on. I'm moving on to the actual stuff. Tell me the answer of this question. Tell me the answer of this question, guys. What do you think? Tell me the answer of this question, everyone. Everyone. As per the question, which of the following series of transition in the spectrum of hydrogen falls in visible region? You have got Lyman, you have got Balmer, combustion, bracket, fund. Okay? This is Lyman series, Balmer, combustion, bracket, PFUND, fund. Okay? Remember one thing. U, V, I, I. U means ultraviolet. V means visible. I means infrared. This also means infrared. This also means infrared. Now select your option. They're asking about the visible. Visible means Balmer. So option B is the one that's the correct answer of this question. Okay. I hope this is also clear. Now guys, one simple question which I believe everyone will solve easily. Quickly guys. Quickly. What do you think about this one? According to the Bohr's theory, which of the following is correct? Representation of the variation of energy and the radius. How do we calculate energy of the electron in the nth Bohr's orbit? E is equal to minus 13.6 z square divided by n square. This is the formula for energy. What is the formula of radius? The radius of nth Bohr's orbit is equal to r naught n square divided by z. Now select your options. Select your options. E is inversely proportional to n square. Or you can say E is directly proportional to 1 upon n square. That's correct. And radius is directly proportional to n square. So it's option B. That is the correct answer of this question. A simple basic question if you remember the formula. That's it. Simple basic question if you just remember the formula. Okay. One more question, my dear students. Calculate the radius ratio of second orbit of He positive and third orbit of Be tri positive. So the ions which are given to me, one is He positive, one is Be tri positive. These are the two ions. Let me call this as number 1. Let me call this as number 2. Calculate the radius ratio of the second orbit. Of He positive, hydrogen, helium. Its atomic number is 2. Right? Let its radius be R1. Similarly, Be tri positive means third orbit. Atomic number, hydrogen, helium, lithium, beryllium, 4. Let its radius be R2. So I have to get the radius ratio over here. And the formula is simple. R1 divided by R2 is equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. N1 ka square. N1 square. 2 ka square is 4 divided by N2 square. 3 ka square is 9. Z1 value, that's 2. Z2 value is 4. So it's going to be 16 divided by 18. That means 8:9. So the radius ratio is coming out to be 8:9 over here, which I was supposed to get. I hope this is also clear to everyone. I'm moving on to one more set of questions. Question based on velocity. Question based on velocity. If the velocity of the electron in the first orbit of hydrogen, so you are given with hydrogen on one side, and you are given with Li di positive on another side. Let me give this number 1. Let me give this number 2. If the velocity of the electron in the first orbit, N1 value is 1. Okay. V1 value is equal to V. If the velocity of the electron in the first orbit of hydrogen is V. Okay. What is the atomic number? Atomic number of hydrogen is 1. What will be the velocity of the electron in the third orbit? So N2 is 3. Hydrogen, helium, lithium. Atomic number is 3. Right? Atomic number is 3. And we have to get the V2 value. My dear students, I hope you remember. V1 divided by V2 is equal. Basically, velocity of the electron in the nth orbit is equal to V0. V0 Z by N. V0 Z by N. I hope you remember that formula. V0 Z divided by N, right? So what is going to be the answer? Quick. What is going to be the answer? Answer is going to be simply V2 is equal to V. Answer is going to be simply V2 is equal to V. So V1 by V2 is equal to Z1 divided by Z2. And this is going to be N2 divided by N1. This is the formula. So V1 is nothing but V. V2 I have to calculate. Z1 by Z2. Z1 divided by Z2. That's 1 by 3. N2 by N1. N2 divided by N1. That is 3 divided by 1. So 3 cancels out. The value comes out to be 1. So V divided by V2. V divided by V2 is 1. Which tells you that V2 is nothing but V. This was to be calculated. So these are some simple questions which can be asked from these formula. Tell me the answer of this question. This I believe you can solve. If not, have a look. The spectrum of helium is expected to be similar to that of what? Helium contains how many electrons? 2 electrons. Which of the following species contains 2 electrons? Li positive. So their spectrum is going to be same. Their spectrum is going to be similar. Right? Their spectrum is going to be similar. Yes, absolutely. When an electron is excited from ground level to the fifth orbit, the number of spectral lines. How do we get the spectral lines? It is N2 minus N1 multiplied by n2 minus n1 plus 1 divided by 2. So n2 value is 5 minus 1, 5 minus 1 plus 1 divided by 2. So 5 4s are 20, 20 divided by 2 is 10. So in total, there will be 10 spectral lines obtained. In total, there will be 10 spectral lines obtained. I hope this is also clear to everyone. This is the formula which you have to remember to calculate the spectral lines. So remember this. Look at this question, guys. This you would have solved in physics as well, I believe. Lambda associated with photoelectron varies with the frequency of the incident light. You would have studied one formula, and lambda is equal to h upon under root of 2m multiplied by kinetic energy. Have you studied this result? Have you studied this result, people? Now, as per your photoelectric equation, h nu is equal to h nu naught plus Ke max. So your Ke max is nothing but it is h nu minus h nu naught. So instead of Ke, what you can write? Instead of Ke, you can write h nu minus h nu naught. So I can say your lambda, it is inversely proportional to what? It is inversely proportional to nu minus nu naught raised power 1 by 2. Because there's a root. So is there any option like that? Is there any option like that? Lambda is inversely proportional to nu minus nu naught raised power 1 by 2. I hope this is also clear to everyone. A simple basic question. One more important question, guys, which you should solve right now. If the uncertainty in the position and uncertainty in the momentum are equal, if the uncertainty in the position and the momentum are equal, then uncertainty in the velocity will be. Uncertainty in the velocity will be. Can you solve this? It's a simple question. Uncertainty in the position and the momentum are same. Give it a try quick. Uncertainty in the position and momentum are same. Uncertainty in the position and momentum are same. What would be the uncertainty in the velocity? My dear students, one result you would have studied, delta x dot delta p. Delta x dot delta p is greater or equal to h upon 4 pi. Now, if delta x is equal to delta p, I can say delta x ka square is greater or equal to h upon 4 pi. Or I can say delta x is greater or equal to under root of h upon 4 pi. Right? This is delta x. One more result you would have solved, you would have studied, delta x dot delta v is greater or equal to h upon 4 pi m. Right? So, instead of delta x, what we can write? Instead of, or I can write it like this, delta v is greater or equal to h upon 4 pi m multiplied by delta x, and delta x already is equal to under root of h upon 4 pi. Under root of h upon 4 pi, right? So your delta v, matter of calculation. Matter of calculation. Let's do one thing. Let's do one thing. Let's do one thing. Let's take the root common. If I take the root common, this comes in the root and becomes h square, right? This comes in the root. This becomes 4 ka square is 16. This becomes pi square. This becomes m square, right? And this already h upon 4 pi. That 4 pi comes up. That 4 pi comes up. So what all things get cancelled out? H and h got cancelled. 4 1, 4 4s are got cancelled, right? Your pi and pi got cancelled. So my final answer will be under root of, in the numerator is going to be h, in the denominator is going to be 4 pi and m square. 4 pi and m square. So what you can take common here? You can take 1 by m common here. 1 by m will be common. It will be under root of h upon 4 pi. 1 by m common, under root of h upon 4 pi. Okay? Is there any option like that? Or you can take 4 also out. If you take 4 out, it becomes 1 upon 2m under root of h upon pi. 1 upon 2m under root of h upon pi. So option A has to be the correct answer of this question. Yeah? So be careful with these calculations. They might mess with you in the examination hall. Be careful with all of this. Be careful with all of this. Tell me the answer of this particular question. It's pretty much simple and I believe you can easily solve. What do you think? The orbitals are called degenerate. The orbitals are called degenerate when they have same energy. right? Orbitals are degenerate when they have same energy. Nothing to think. Nothing to think in this question. You are given with psi square versus r graph, and the graph is starting from the top, and all the graphs between psi square versus r or psi versus r, which start from top, they are for s orbital. They are for s orbital. So it's understood, it's s. Now, how many nodes are there? There is one node. There is one node. Okay, there is one node. My dear students, total number of nodes is given by the formula n minus 1. So total number of nodes are 1 here. So that means n value is equal to 2. If n is 2, the orbital has to be 2s. The orbital has to be 2s, right? The orbital has to be 2s. The orbital has to be 2s. I hope this is also clear to every one of you. Look at this. A certain orbital has 0 angular nodes. Angular nodes are given by the value of L. Angular nodes are given by the value of L. L is 0. And 2 radial nodes. Radial nodes are given by n minus L minus 1. That is 2. N minus L minus 1. That is 2. The orbital is L value is equal to 0. L value is 0 for S. So, L value is 0 for S. So, tell me the answer of this question. Quick. Quickly, guys. Quickly. So, is it A or B? Is it A or B? Is it A or B? Quick. I gave you the answer already. Absolutely, all of you are perfectly right. It's option B. It's option B. Orbital has 3 angular nodes. Angular nodes means the value of L. L is 3. And 3 total nodes. Total nodes is equal to n minus 1. That is 3. That is 3. Tell me the answer. 3 angular nodes, 3 total nodes. Which one is going to be? Which one is going to be? I give you the formula. This formula gives you the total number of nodes. This value gives you the angular nodes. Now tell me the answer quick. Which one you are going to select? Which one you are going to select? Which one you are going to select? Every one. Formulas already you have. Total number of nodes, angular nodes. All of you are perfectly correct. It's absolutely going to be option D. That will be the correct answer. Okay, what about this one? The number of spherical nodes in 3P. Spherical nodes means radial nodes. Radial nodes are given by the formula n minus L minus 1. Right? N minus L minus 1. This gives me the radial nodes, or you call them as the spherical nodes. Now for 3P, n value is equal to 3. L value for P is 1. Right? So it is 3 minus 1 minus 1. The value comes out to be 1. So radial node is 1 in case of 3P. Radial node is 1 in case of 3P. This sort of a question is also asked. This is your favorite question, right? N plus L rule. More the value of N plus L, more the energy. More the value of N plus L, more the energy. Okay, more the value of N plus L, more the energy. In case of 5F, N value is 5. For F, the value of L, SPDF, L value is 3. So 5 plus 3 is 8. N plus L value is 8. In case of 6P, N value is 6. For P, L value is 1. 6 plus 1 is 7. Then it comes 5P. N value is 5. For P, L value is 1. 5 plus 1, 6. Then 4D. N value is 4. For D, L value is 2. 4 plus 2, 6. We have to give the decreasing order. So maximum N plus L is for 5F. So 5F's energy will be maximum. Then comes your 6P. Right? Now among these two, which one has got more N? 5P has got more N. Comes 5P. Then comes your 4D. This is the decreasing order of energies of these orbitals which are given to me. Just based on N plus L. And for those orbitals which have got same N plus L, decide on the base of N. More the N, more the energy. That's it. Right? This sort of a question you should know. Have a look on this one. Orientation of atomic orbital is given by which quantum number? Magnetic quantum number. Orientation of orbital is given by which orbital? Which quantum number? Magnetic quantum number. Similarly, your principal quantum number, it gives the idea about the size and energy. Principal quantum number, it gives the idea about the size and energy. Your magnetic quantum number, it gives the idea about the orientation. Okay, it gives the idea about the orientation. What about this question? I want you to let me know in the chats quickly, guys. two electrons occupying the same orbital are distinguished by, they are distinguished by spin quantum number. They are distinguished by spin quantum number. One will be going with clockwise spin, another one will be going with anti-clockwise spin. So again, nothing to think over this. The orbital angular momentum. Orbital angular momentum is given by the formula under root of L into L plus 1 h upon 2 pi, right? Now for P the value of L is 1. So it is 1 into 1 plus 1 h upon 2 pi. So it's going to be simply root of 2 h upon 2 pi, or you can write it as h upon under root of 2 pi. Either this will be the option or this will be the option. H upon root 2 pi. So option A is the one which is correct. Right? These are some simple questions, my dear students, which are asked. Now look at this one. This is again the question that has been asked in your JEE mains examination. The correct set of 4 quantum numbers for the valence electron of rubidium. Rubidium, right? Lithium, sodium, potassium, rubidium. Outermost configuration of lithium is 2s1. Outermost configuration of sodium is 3s1. This is 4s1. This is 5s1. So the last electron in rubidium is present in 5s1. Okay, this is the last electron of rubidium. So what is the n value here? N value is 5. What is the L value for S? L value is 0. For S orbit, for S subshells, L value is 0. What is M? M is from minus L to plus L. So if L is 0, M is 0. What can be spin? Spin can be either plus 1 by 2 or minus 1 by 2. Plus 1 by 2 or minus 1 by 2. So select your options. Select your options. Select your options, my dear students. So what is going to be the correct option for this particular one? N value is 5. L value is 0. M value is 0. And spin plus 1 by 2. So I believe option C is the one that's going to be the correct answer of this particular question. Right? I hope you got to know how I solved this one as well. Alright. Which of the following set of quantum numbers is not possible? How do you check that? First of all, remember, the value of L is from 0 to n minus 1. This is the value of L. The value of M is from minus L to plus L. Minus L to plus L. And spin can have two values, either plus 1 by 2 or minus 1 by 2. Now, if this is 3, this is 0. 0 to n minus 1, 0 to 3 minus 1. That means 0 to 2. It can be 0, 1, 2. It's correct. M value is 0. M is from minus L to plus L. So 0 only. So this is correct. This is correct. Look at the second one. N is 2. M is from 0 to n minus 1. So 0 to 2 minus 1. 0 to 2 minus 1. So 0 to 1. Either 0 or 1. So this is incorrect. This is incorrect. Now this is 4. This is 3. This is minus 2. This is minus 1 by 2. This is also correct. This is 1. This is 0. This is minus 1. Check this M value. M is from minus L to plus L. L is 0. So M can have only one value, that is 0. But it is showing minus 1. So it is incorrect. 3, 2, 3. Look at this value. M value is from minus L to plus L. So minus 2 to plus 2. So it's going to be either minus 2, minus 1, 0, plus 1, plus 2. Here they are showing 3. So this is also incorrect. So which of the following set of quantum numbers is not possible? It's going to be option 2, option 4, option 5. 2, 4, 5 are not possible. So option B is the correct answer of the question. Did you understand this? Did you understand this, people? Did you understand? Similar type of question which you can solve. Similar type of question, my dear students, which you can solve. What do you think? I want your answer in the chats. Which of the following arrangements is possible? They are telling is possible. Which of the following arrangements is possible? So tell me. Which of the following arrangements is possible? M value here is 2, but M is from minus L to plus L. Is this correct? It is correct only. So which one is wrong? Which one is wrong? I mean, which one is correct? Which of the following is possible? It is option A only which is possible. Option A is possible. 5, 2, 2 plus 1 by 2, it's possible. Right? This is not possible. If N is 2, L has to be from 0 to n minus 1. So either 0 or 1. This is not possible. Right? Even this is not possible. This is also not possible. So option A is the one which is possible among all. I hope this is clear. So ready for chemical bonding now? Ready for chemical bonding, from which almost like 4 questions are asked every year. And people get those 4 questions from this session only. Ready for bonding? Or do you need a break? Okay, let's take a 10-minute break. Let's take a 15-minute break. Break till 10 p.m. I want every one of you to be back by 10 p.m. sharp. Okay, so 15-minute break this is going to be. But be back quick, people. Be back quick. Be back quick. Okay? I want every one of you to be back. Otherwise, there is no fun in continuing the session. Otherwise, there is no fun in continuing the session. So I want you guys to be back on time. 15-minute break I'm giving. Go have your dinner quick and come back. See you in a while. Is everyone back? Is everyone back? Yes. Are you guys done with your dinner? Or not? Are you guys done? Guys, tell me quickly. I do not want the chats to be so slow. I want the chats to be fast. Okay, ready for chemical bonding? Ready for chemical bonding? Ready for chemical bonding? All right. So, my dear students, the first question of the chemical bonding, which is your confidence booster, right? Which everyone is going to let me know in the chats. The force of attraction that holds the constituents together in a molecule. What do we call this force of attraction as? What is it? This is never going to be asked in the exam though. I've just kept this question so that you can answer this. It is going to be what? It is going to be chemical bond, right? It is going to be chemical bond. Second one, again a basic question. Again a basic question. Cation and anion combines in a crystal to form which of the type of the compound? Quickly, what is going to be the answer of this one? What is going to be the answer of this one? Everyone. Your cation and anion will be held by the ionic bond. It will be held by the ionic bond. The third simple question, which I believe every one of you can easily tell me in the chats. When the metal atom combines with the non-metal atom, the non-metal atom is going to gain electrons. The non-metal atom is going to gain electrons, and its size, when the non-metal atom gains electrons, its size increases, right? Its size increases. Okay? Again, simple basic. Size increases. Again, a simple basic question. Which of the following does not represent the correct Lewis structure? Which of the following does not represent the correct Lewis structure? In case of carbon, there are 4 valence electrons, and all the 4 valence electrons are shown here. In case of oxygen, 6 valence electrons, only 5 are shown. In case of neon, 8 valence electrons, only 6 are shown. In case of beryllium, 2 valence electrons, both the ones are shown. And all the 3 are shown in case of boron. So which of the following does not represent the correct Lewis structure? It's 2 and 3. Where is 2 and 3? It's option D. Simple question. Simple and basic one. According to Fajan's rules, covalent bond is favored by smaller cation, larger anion. Smaller cation, larger anion. Covalent bond is favored by smaller cation, larger anion. Right? The sequence of polarizability of anions. When you talk about the polarizability of anions, that is directly proportional to the size of anions. More the size of anion, more the size of anion, more the polarizability. So which anion has got maximum size? I negative. If I negative has maximum size, it has got maximum polarizability. So I negative, Br negative, Cl negative, F negative. This is the polarizability. Okay. Yes, you can watch it for the EAPCT exam as well. I hope this is clear. Give the order of the covalent character. You have to give the order of the covalent character. My dear students, first of all, if you look carefully, this is Li positive, Cl negative, Be di positive, Cl negative, B tri positive, Cl negative, C plus 4, Cl negative. So first of all, anion everywhere is same. Anion everywhere is same. You are not going to decide as per anion. You will be deciding as per cation. And remember, covalent character is directly proportional to polarizing power of cation. And polarizing power of cation is directly proportional to charge on cation and inversely proportional to size of cation. Okay. So more the charge on cation, more the polarizing power, more the covalent character. What is going to be the order? What is going to be the order? Order is going to be CCl4 will have maximum covalent, followed by BCl3, followed by BeCl2, followed by LiCl. This is the order here. Simple basic question. Right? Perfect. Questions on Fajan's rules are frequently asked. The maximum covalent character is shown by Al tri positive, Cl negative, magnesium di positive, Cl negative, cesium positive, Cl negative, Sn di positive, Cl negative. So do not decide on the basis of anion because anion everywhere is same. So talk in terms of cation. More the charge on cation, more the polarizing power of cation, more the covalent character. So it's option A. It's option A, maximum covalent character. Okay, maximum covalent character. Select the most ionic and most covalent. Most ionic and most covalent. Most ionic means least covalent. Most ionic means least covalent. So basically you have to select least covalent and most covalent. You have to select least covalent and most covalent. First of all, this Pb is in di-positive state here. This manganese will be in +7 oxidation state, right? More the charge on cation, more is going to be the polarizing power, more the covalent character. So this one will be having maximum covalent. This one will be having minimum covalent. So it's option B. That's going to be the correct answer of the question. Simple and basic rules I'm using, and we are solving the questions easily. What about this particular question? Quick. The question based on your dipole moment. The question based on your dipole moment. The question based on your dipole moment. What do you think? Which of the following set of molecules will have zero dipole moment? Which of the following set of molecules will have zero dipole moment? First of all, if you talk about BF3, it's a common molecule, BF3, which has got the net dipole moment 0. Very common molecule. BEF2. BEF2. It is again one molecule which has got net dipole moment 0. Why is that? Why is that first of all? Among beryllium and fluorine, more electronegative is fluorine, so delta negative, delta positive. Here also delta negative, delta positive. Bond moment is in this direction. Here the bond moment is in this direction. They get cancelled out, so net dipole moment 0. Carbon dioxide, again the similar type of molecule, net dipole moment 0. Okay. 1,4-dichlorobenzene. 1,4-dichlorobenzene, right? Again a molecule whose net dipole moment is 0. It's the asked question as well. So it's option C, right? Which shows you all the molecules having net dipole moment 0. A simple basic question again this is. Now my dear students, look at this one. Give the order of the dipole moments. Remember, more the electronegativity difference, more is going to be the dipole moment. More the electronegativity difference, more is going to be the dipole moment. Now first of all, among all these options you have got BF3. BF3 has got zero dipole moment. Its dipole moment is going to be least, right? So it's either going to be C or D, right? It's either going to be C or D. Now among NF3 and NH3, where is the electronegativity difference more? Electronegativity difference is more in case of N and H. In case of N and H, electronegativity difference is more. So I would say NH3 has got more dipole moment than that of NF3. So I believe it's going to be option C. That will be the correct answer of the question. NH3 has got more dipole moment than that of NF3. Remember this particular point. I've taught you many a times in the marathons. Okay. This question everyone should answer on their own. What do you think? What do you think? You've got a neutral molecule XF3 that has a zero dipole moment. XF3, that means it is going to be BF3, right? We know it already. BF3 has got zero dipole moment. Perfect. There is nothing to think a lot about this. It's a simple basic one. Now, which of the following possesses the dipole moment? Which of the following possesses the dipole moment? My dear students, let me tell you one thing. Any molecule of the type AB2L0, any molecule of the type AB3L0, AB4L0, AB5L0, AB6L0. Similarly, for example, you have got AB2L3, you have got AB4L2. These are the types of the molecules which have got zero net dipole moments. Their net dipole moments are zero. And any molecule which has got net dipole moment zero, you call those molecules as non-polar molecules. So you have to basically identify the types of the molecules here. You have to identify the types of the molecules. If you look at the first molecule is of the type AB6L0. AB6L0. Second molecule is of the type AB2L1. Third molecule is of the type AB2L2. And fourth molecule is of the type AB4L1. Okay. So, which of the following possesses dipole moment? See, this won't be possessing dipole moment. This will be possessing. This will be possessing. Even this will be possessing. Right? So, it is B, C, D. So, option C is the one that is going to be the correct answer of this question. You just have to see the type of the molecule. Just check the type of the molecule and you can get the question killed. That's it. Okay? That's it. In which of the molecule do you see PP overlapping? In case of hydrogen molecule, in case of HBr, in case of HCl, in case of Cl2. Where do you see PP overlapping? So first of all, this hydrogen, it's SS overlap. This is SP overlap. This is SP overlap. This is PP overlap, right? So in case of Cl2 molecule, you see PP overlapping, right? In case of Cl2 molecule, you see PP overlapping. You see PP overlapping. Where do you see zero overlap? Over here, it is a positive overlap, same sign on same side, so positive overlap. Positive overlap. Opposite sign on same side, it's a negative overlap. Do you see any overlap here? Do you see any overlap here? This is the zero overlap. This is the zero overlap. Okay? It is a zero overlap. Simple. It is a zero overlap. One basic question. Correct order of bond energy. See, more the bonds in between, that means more the force of attraction. That means more energy is required to break it. So I will say C triple bond C will have more bond energy than that of C double bond C, than that of C single bond C. Again, one basic question. Again, one basic question this is. The molecule not having pi bonds. Molecule not having pi bonds. Cl2 molecule is a single bonded one. O2 molecule, I hope you remember its structure. N2 molecule, you should know its structure. N triple bond and carbon dioxide is this one. So which molecule does not involve any pi bonds? It's Cl2 molecule which does not involve any pi bonds. Okay? Cl2 molecule does not involve any pi bonds. Which of the following molecules represents the correct hybridization from left to right? sp2, sp2, sp, sp. First of all, look at this particular carbon. This carbon is forming 3 sigma bonds. 2 with carbon, 2 with hydrogen, 1 with carbon. 3 sigma bonds means sp2. This is also forming 3 sigma bonds, sp2. This forming 2 sigma bonds, so this sp. This forming 2 sigma bonds, so this also sp. So sp2, sp2, sp, sp. That means option B has to be the correct answer. Perfect. All of you are giving the correct answer. That's great. That's amazing. Okay. In case of D to sp3 hybridization, which d orbitals are involved? Which d orbitals are involved in D to sp3? Remember, it is dx square minus y square and dz square. I'll tell you something. In case of sp3d hybridization, it is dz square which is involved. In case of sp3d2, dz square and dx square minus y square. This is involved. And in case of sp3d3 hybridization, it is dxy, dx square minus y square and dz square. Right? These 3 d orbitals are involved in sp3d3 hybridization. So remember all the 3 points. Anything can be asked out of these 3. Anything can be asked out of these 3. For example, you have got a question here. This is the question. AsF5 molecule. AsF5. AsF5. Check its hybridization first of all. This is the central atom. It has got some 5 valence electrons. Arsenic, 5 valence electrons. How many sigma bonds it's forming? It's forming 5 sigma bonds. Will there be any lone pair on arsenic? No. Steric number will be 5 plus 0. That's 5. Hybridization involved is sp3d. So which d orbital is involved here? It is dz square which is involved. So dz square is involved. So there is only one option which is saying dz square is involved. So it has to be option C only. It has to be option C only, right? I hope I'm clear with this. I hope I'm clear with this. Yeah? Perfectly done, guys. Perfectly done. Perfectly done. The correct geometry and hybridization of XeF4. Okay, let me modify this question. Make it like this. The correct shape and hybridization for XeF4. First of all, if I talk about XeF4, xenon has got how many valence electrons? 8. How many sigma bonds it's forming? 4 sigma bonds. How many lone pairs will be on xenon? 2. Right? What is the type of the molecule? AB4L2. AB4L2. What is the steric number? Sigma plus lone pair, 6. Hybridization, sp3d2. Right? And in case of AB4L2, the shape is going to be square planar. The shape is going to be square planar. So it's square planar and sp3d2. Right? Again, a basic question. You should know it. You should know it. Which of the molecule has got the bond angle of 120? AB3 type molecule. AB3 type, AB3L0 type molecule has got the bond angle of what? 120 degree. Okay. If you talk about BCl3, BCl3, boron does not have any lone pair. So it is the type of the molecule is AB3L0. If it is AB3L0, its bond angle has to be 120. Its bond angle has to be 120, right? Its bond angle has to be 120. Again, a basic question. This question, I believe, you can easily solve. Tell me its answer quick. Tell me its answer quick in the chats. I want to know this. I want to know this. Quick. First of all, bond angle in case of water is 104 degree 5 minutes and not 109 degree 20 minutes because of the lone pair repulsions, right? Is that? Majority is already given the correct answer. That's great. It's lone pair repulsions. Tell me the answer of this question. Shapes of PCl5, BrF5 and IF7, right? If I talk about PCl5, the type of the molecule is AB5L0. In case of BrF5, the type of the molecule is AB5L1. In case of IF7, the type of the molecule is AB7L0. Right? This particular molecule has got the shape of trigonal bipyramidal. This particular one has got the shape of square pyramidal. Square pyramidal. This is going to be pentagonal bipyramidal. Now check the answer. One of the given compound is square planar. Yes, one of the given compound is square planar. One of the given compound is square planar. Right? Perfectly done. In which of the molecule there are more than one lone pairs on the central atom? More than one lone pairs. If you talk about XeF2, xenon has got some 8 valence electrons. Out of 8, it is forming 2 sigma bonds. Right? So there will be 6 electrons left as such on xenon in the form of 3 lone pairs. So on xenon, there will be more than one lone pair. It's pretty much simple. Nothing to think a lot about this one. XeF2 is isostructural with. XeF2 is isostructural with. If you talk about XeF2, as I told you a few minutes back, this xenon has got 3 lone pairs. So the type of the molecule is AB2L3. Now, which of the following molecule is again of the type AB2L3? Which of the following molecule is again of the type Ab2L3? If you look at the first molecule, ICl2 negative. ICl2 negative. Valence electrons on iodine are 7, but there is a negative charge, so 7 plus 1 makes it 8. How many sigma bonds? 2 sigma bonds. So out of 8 valence electrons, 2 valence electrons are utilized to form 2 sigma bonds. So 6 electrons will be left as such in the form of 3 lone pairs. So again, the type of this molecule is also Ab2L3. So if these two molecules have got the same type, that means they are going to be isostructural. They are going to be isostructural. Remember this particular point as well. Okay? Remember this particular point as well. All right. Let's move on to one more question. Just a second. Tell me the answer of this one. Tell me the answer of this particular question. Identify the wrongly matched pair. Identify the wrongly matched pair. NH3. What is the type of this particular molecule? It is Ab3L1 type. PCl5 is Ab5L0 type. SF6 is Ab6L0 type. BeCl2 is Ab2L0 type. Now Ab3L1 means pyramidal. So this is correctly matched. Ab5L0 is trigonal bipyramidal. But here it's mentioned as trigonal planar. So this is wrong. This is wrong. We were supposed to identify the wrongly matched pair. So option B. Option B is wrongly matched. Option B here is wrongly matched. Option B is wrongly matched. What type of hybridization is involved in xenon in case of XeOF4? If I talk about XeOF4, xenon being the central atom has got 8 valence electrons. How many sigma bonds it's forming? 5 sigma bonds. So out of 8 valence electrons, 4 of this and 2 of this, 6 valence electrons are utilized. So 2 electrons are left in the form of a lone pair. So there is one lone pair. The type of the molecule is Ab5L1, right? Steric number is sigma plus lone pair, 5 plus 1, 6. Hybridization involved is going to be sp3d2. sp3d2. Option C, that's correct. Option C, that's correct, right? Again, a simple question this was. Again, a simple question this was. Which of the molecule does not exist? Which of the following molecule does not exist? What do you think? Which of the following molecule does not exist? First of all, that particular molecule whose bond and order is less or equal to 0, we say that molecule does not exist. That molecule does not exist. And remember, all your 14 electron species, they have got bond order of 3. 15 electron species have bond order of 2.5. 16 electron species have got the bond order of 2. 17 electron species have got the bond order of 1.5. 18 electron species have got the bond order of 1. 13 electron species have got the bond order of 2.5. 12 electron species have got the bond order of 2. 11 electron species have got the bond order of 1.5. And 10 electron species have got the bond order of 1. Okay. Now, this is one trick which you have to remember to calculate the bond order. But here in this particular case, we have to identify the molecule that does not exist. My dear students, it's going to be He2, whose bond order is less or equal to 0. How do we calculate bond order? Bond order is equal to half of electrons in bonding molecular orbital minus anti-bonding molecular orbital. Half of the electrons in bonding minus anti-bonding molecular orbital. So first of all, in case of He2, there are 4 electrons. In case of He2, there are 4 electrons. So its configuration is going to be sigma 1s2, sigma star 1s2, right? So there are 2 anti-bonding electrons, 2 bonding electrons. So bond order is going to be equal to half of number of electrons in bonding minus anti-bonding. The value comes out to be 0. And that particular molecule wherein the bond order comes out to be 0, that does not exist. That does not exist. So it's option 2, which is going to be the correct among all. Which of the following molecules is paramagnetic? Which of the following is paramagnetic? What do you think about this one? Which of the following is paramagnetic? So first of all, remember this is the O2 molecule basically, which is paramagnetic. Because when you write its molecular orbital configuration, there will be 2 unpaired electrons. When you write its molecular orbital configuration, there will be 2 unpaired electrons. And unpaired electron means paramagnetic. This is the molecular orbital configuration of your O2. Since in O2 there are 16 electrons. So 2 here, 4, 6, 8, 10, 12, 14, 15, 16. So there are 2 unpaired electrons, one in pi star 2py, 1 pi star 2px, right? 2 unpaired electrons. 2 unpaired electrons means it is definitely going to be paramagnetic. Okay? Unpaired electron simply means paramagnetic. How many antibonding electrons are in O2? How many total antibonding electrons are in O2? In O2, you write the molecular orbital configuration. When you write the molecular orbital configuration, calculate the total number of antibonding electrons. So star. So 2, 4, 2, 4, 5, and 6. So there are in total 6 antibonding electrons in case of O2. So your answer here has to be 6. Your answer has to be 6. When O2 is converted into O2 negative, so basically you are giving 1 electron to O2 and it is getting converted to O2 negative. In which molecular orbital this 1 electron goes into? In which one molecular orbital this 1 electron goes into? It goes into pi star 2px. It goes into pi star 2px. You saw it right now. Pi star 2px1, pi star 2py1. So 1 electron will go into pi, the extra electron will go into pi star 2px, right? The extra electron will go into pi star 2px. I hope this sort of a question you can easily solve from now on. Which of the following pairs have got same bond order? Remember a point. Remember a point. Isoelectronic species. When you talk about your isoelectronic species, their bond order is going to be same always. Isoelectronic species means those species which have got same number of electrons. Now, which one are isoelectronic? If you talk about the second option, Cn negative and CO. In case of Cn negative, how many electrons are there? Carbon has got 6 electrons, nitrogen has got 7, there is a negative charge, so the value comes out to be 14 electrons. This carbon has got 6 electrons, oxygen has got 8, so this also has got 14 electrons. So these two species have got same number of electrons. Same number of electrons means isoelectronic, and isoelectronic species, what do they have? They have got the same bond order, right? They have got the same bond order. And if you talk about the 14 electron species, in case of 14 electron species, the bond order is definitely going to be 3, right? Bond order is definitely going to be 3. What do you think about this one? Cn negative, CO and NO positive. All the 3 are isoelectronic, 14 electron species. All the 3 are isoelectronic, 14 electron species. So their bond order is same. How much? It's going to be 3. Okay, it's going to be 3. I hope these sort of questions you can easily solve from now on. Okay, I hope these sort of questions you can easily solve from now on. Now, I'm moving on to one more chapter, that is thermodynamics. So all ready for thermodynamics? All ready for thermodynamics, people? Quick in the chats. All ready for thermodynamics? Yeah? Tell me, have you studied this chapter before? Have you studied this particular chapter before? I'll give the break after thermo. I'll give the break after thermodynamics. Let's complete this first. Okay. The first question is, out of these following properties, which of the following are intensive, basically? Intensive properties. What are extensive properties and what are intensive properties? Extensive properties are the ones whose value changes on changing the size of the system. Intensive properties are the ones whose value does not change on changing the size of the system. Now, internal energy, it is extensive. It is extensive. It changes on changing the size of the system. Boiling point, it is intensive. pH is intensive. EMF is intensive. Right? So the intensive properties are your 2, 3 and 4 here. So 2, 3 and 4 are intensive. Okay? One simple question this is. My dear students, look at the next one. Molar entropy and temperature. Temperature is first of all the example of intensive property. This is intensive. This is intensive. Entropy is extensive. Entropy is extensive. But whenever extensive property is expressed per unit mole, whenever an extensive property is expressed per unit mole, so entropy expressing per unit mole, it becomes molar entropy. Whenever an extensive property is expressed per unit mole, the new property that comes into existence, that is going to be intensive always. That's always going to be intensive. So both of them are intensive. So extensive property expressed per unit mole or per unit mass or per unit volume. The new property that comes into existence, that is going to be always your intensive property. Okay? So both of them are intensive properties. Which of the following are not state functions? Which of the following are not state functions? So first of all, whenever you are asked about state functions, remember these 7 terms: P, V, T, internal energy, enthalpy, entropy, Gibbs free energy. Okay? These are your state functions. These are your state functions. Pressure, volume, temperature, internal energy, enthalpy, entropy, Gibbs free energy. Remember these 7 terms. They are important. They are your state functions. Now, as per the following, which of the following are not the state functions? Your heat and work. Heat and work, they are not the state functions, they are the path functions. Right? Which of the following are not state functions? So Q and W, they are not the state functions, they are the path functions. Q plus W is equal to delta U as per first law. H minus TS. H minus TS is basically your Gibbs free energy. Right? So Gibbs free energy as well as internal energy, they are state functions. Heat and work, they are the path functions. So what is the answer? You already got the answer now. What about this particular question? What do you think? When freezing of liquid takes place, when liquid is freezed, when liquid is frozen, what happens? When freezing of liquid takes place, what happens? When liquid is frozen, you have got a liquid and you are converting this liquid into solid. You are converting this liquid into solid. So when liquid is converted into solid, what happens? Heat is released by the system. And whenever heat is released by the system, Q value as per sign conventions is going to be negative. Q value as per sign conventions is going to be negative. Okay? Whenever heat is released by the system, Q value is taken to be negative. So when you are freezing a liquid, that means heat will be released by the system. And when heat is released, Q value definitely has to be taken as negative. I hope this question is clear. 3 moles of an ideal gas expanded spontaneously in vacuum. Whenever an ideal gas undergoes an expansion in vacuum is what you call as free expansion. In case of free expansion, work done is always 0. In case of free expansion, work done is always 0. So whenever in a question they will mention vacuum, remember W value has to be 0 directly. Remember W value has to be 0 directly. Okay? A system is going from A to B through different paths. Path 1, path 2, path 3. Pressure volume curve. We have to get the magnitude of work. Remember, area under PV curve. Area under PV curve gives us what? It gives us the magnitude of work. Area under PV curve gives me the magnitude of work. So, area under which curve is more? I'll say area under this third curve is more. Right? If area under third curve is more, that means magnitude of W in 3 will be more. So simply you can say W3 has to be greater than W2, which has to be greater than W1. As simple as that. Okay? As simple as that. Now, my dear students, one more simple question. I hope you can easily solve this. What do you think about this one? Quick, in the chats. What do you think about this one? Quickly. Quickly. Quickly, guys. In the question, if you look carefully, if the gas expands against vacuum, in vacuum, so it's again the case of free expansion. I told you in the question, wherever you see vacuum mentioned, that means the case is free expansion. And in case of free expansion, what is the value of W? W value is 0. W value is 0, right? W value is 0. Okay. An ideal gas is allowed to expand from 1 liter from 1 liter to 10 liters against a constant external pressure. Against a constant external pressure of 1 bar. We have to calculate the value of work done. My dear students, first of all, remember, whenever in a question, they'll mention that external pressure is constant. Whenever in a question, they'll mention that external pressure is constant. That means the process is irreversible. And how do we calculate work done in irreversible processes? It is simply minus P external delta V, which is V2 minus V1. What is P external? P external is 1 bar. V2 minus V1, 10 minus 1 is 9. So the units of this is bar, this is liter. The unit of it is going to be bar liter. But as per the question, I have to give the answer in kilojoules. Remember, 1 bar liter is nothing but 100 joules. If 1 bar liter is 100 joules, it's going to be minus 9. Instead of bar liter, write 100. And the answer is in joules. But I need the answer in kilojoules. So I'll be dividing simultaneously with 1000. Then the answer is going to be coming in kilojoules. So 0000 cancel. The value comes out to be minus 0.9 kilojoules. This is the final answer. Minus 0.9 kilojoules. Right? This is the value of work. This is the value of work. Okay? This is the value of work. A simple basic question. I would expect the answer from everyone for this. For 2 moles of ideal gas, Cp minus Cv will be? For 2 moles of ideal gas, Cp minus Cv will be? For 2 moles of ideal gas, Cp minus Cv will be? First of all, for 1 mole of ideal gas, Cp minus Cv is R. So for 2 moles of ideal gas, Cp minus Cv will be 2R. For 3 moles of ideal gas, Cp minus Cv will be 3R. Right? So the answer of this question will be simply 2R. Cp minus Cv is equal to 2R for 2 moles of ideal gas. Okay? For 2 moles of ideal gas. What about this sort of a question? Look at this question. In a closed insulated container, insulated means Q value is 0. No heat exchange between system surroundings. A liquid is stirred. We are stirring the liquid. We are stirring the liquid. Liquid is my system. And we are stirring the liquid. So work is done on the system. Work is done on the system. And whenever work is done on the system, W value is taken to be positive. In chemistry. W value is taken to be positive in chemistry. Okay, which of the following is correct? So first of all, Q is 0. If Q is 0, use the first law. Delta U is equal to Q plus W. But Q is 0. So delta U has to be equal to W. But this W is non-zero. It is positive. W is non-zero. So delta U and W, they are equal and both of them will be non-zero. And at the same time, Q is 0. So find an option which satisfies this particular part. Find an option which satisfies this. So it's going to be delta U and W both are equal, but are non-zero. But Q value is equal to 0. So this was the question. This was the question. Let's solve this one. During the compression of spring, we are compressing the spring. Spring is that system. We are compressing the spring. Work done is 10 kilojoules. Since we are compressing the system, whenever there is compression, work is done on the system. And whenever work is done on the system, W value is positive. So W is nothing but plus 10 kilojoules. Okay. 2 kilojoules of heat escape to the surroundings. 2 kilojoules of heat is going to the surroundings from the system. So that means system is releasing heat. And whenever system releases heat, Q value is taken to be negative. How much is that? That is minus 2 kilojoules. As per the question, I'm supposed to calculate delta U. Delta U is equal to Q plus W. Q value is equal to minus 2. W value is equal to plus 10. The value comes out to be plus 8 kilojoules. So this is the value of delta U. That is plus 8 kilojoules. That is plus 8 kilojoules. I hope this is also clear to everyone. Plus 8 kilojoules. Okay. I hope you are understanding how I'm trying to solve these questions. Delta U is equal to what? Delta U is equal to what? Since you know, delta U is equal to Q plus W. Now, as per the question, delta U is isochoric work, isobaric work, adiabatic work, or isothermal work. When can delta U be equal to W? When can delta U be equal to W? When Q is 0. And when Q is 0, what we call that process as adiabatic. So can I say delta U is basically equal to adiabatic work? Delta U is nothing but adiabatic work. Okay, delta U is equal to adiabatic work. Be careful with these questions as well. These are simple but confusing. Right? You can make silly mistakes in these sort of questions, I believe. Look at this particular question. Look at this particular question. 1 mole of ideal gas is heated at constant volume Volume is constant. If volume is constant, W value is 0. If volume is constant, W is 0. The temperature raised from 298 Kelvin to 308 Kelvin. If heat is supplied to the gas, if the heat supplied to the gas is 500 joules, that means the gas is absorbing heat. And when the heat is absorbed by the gas, Q value is positive. How much? Plus 500. We have to check the options. So first of all, as per first law, delta U is equal to Q plus W. Since W is 0, that means delta U is equal to Q. And Q value is nothing but, that is plus 500. That is plus 500. So delta U and Q both are equal. Their value is plus 500. And at the same time, W value is also 0. Find an option which satisfies this. Find an option. Delta U and Q both are equal, both are 500, and W value is 0. So this is the correct answer of the question. This is the correct answer of the question. All clear, guys? All clear? All clear till here? All right. Let's move on to one more then. Let's move on to one more. We are given with a graph between enthalpy and temperature, right? We have to check at point A or point B, where is the Cp value more? Where is the Cp value more? I believe you would have studied this particular result sometimes. dH is equal to NCp dt. dH is equal to NCp dt. And since we are given with 1 mole of the ideal gas, so N value is 1. Therefore, Cp is nothing but dH upon dt. What is dH upon dt? dH upon dt means slope of the tangent at a point on enthalpy versus temperature curve. Okay. So I'll say more the slope of the tangent, more the Cp. So now you can draw two tangents, one here and similarly one here. Okay. Which tangent has got more slope? The tangent at point A has got more slope, more the Cp value. So I would say Cp at A is greater than that of Cp at B. Simple question. Yeah. A simple and basic question this is. Simple and basic question this is. In which of the following delta H and delta E are equal? Delta H and delta E. You know the relation delta H is equal to delta U plus delta NGRT. Either you can write delta U here or delta E. The choice is yours. Now the question says, in which of the following? In which of the following delta H and delta U are equal? So first of all, delta H and delta U will be only equal if delta Ng is equal to 0. If delta Ng is equal to 0. In which of the reaction delta Ng is 0? Tell me that. If you talk about the last reaction, delta Ng is number of moles of gaseous products minus number of moles of gaseous reactants, which is 1 plus 1, 2. So 2 minus 2 is 0. If delta Ng is 0, that means delta H and delta U would be equal in the fourth case. It will be equal in the fourth case. I hope this is also clear. 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 Okay, look at the next one, guys. Look at the next one. Calculate the work done in joules when 4.5 grams of H2O2 reacts against a pressure of 1 atm at 25 degrees centigrade. So basically, you have to calculate work done during this process. And work done during a reaction is basically given to me as minus delta NGRT. This is minus delta NGRT, right? Now, first of all, tell me one thing. How many moles of H2O2 are we given with? How many moles of H2O2 are we given with? Mass of H2O2 divided by molar mass of H2O2 would be 34. So these many moles of H2O2 we are given with, right? These many moles of H2O2 we are given with. Now, first of all, if I calculate delta Ng for this reaction, delta Ng means number of moles of gaseous products, which is 1, minus number of moles of gaseous reactant, which is 0. So delta Ng is 1 basically. If delta Ng is 1, W would be equal to minus times delta Ng RT. So minus delta Ng value is 1. Delta Ng value is 1. Okay. We have to calculate work done in joules. So R value has to be 8.314. Okay. Temperature is given to me as how much? 25 degrees centigrade. That means 298 Kelvin. So this is the value of work done. But my dear students, this is not going to be the answer of the question. This is not going to be the answer of the question. Because this is the value of work done for the decomposition of 2 moles of H2O2. So when we are doing the decomposition of 2 moles of H2O2, the value of W is equal to how much? The value of W is minus 813 multiplied by 298 joules. Correct? This is the value of W for the decomposition of 2 moles of H2O2. But as per the question, do we have to do the decomposition of 2 moles of H2O2? No. We have to do the decomposition of these many moles of H2O2. So if 2 moles of H2O2 undergoes decomposition, W value is this much. Therefore, when 1 mole of H2O2 undergoes decomposition, what is the value of W? It is multiplied by 298 divided by 2. Therefore, when 4.5 divided by 34 moles of H2O2 undergoes decomposition, W is going to be into 298 divided by 2 multiplied by 4.5 divided by 34. Matter of calculation and get the answer. This is the final answer. You have to be careful with this sort of a question, guys. Be careful with this sort of a question. Don't write the answer as this directly. This is the value of W for the decomposition of 2 moles of H2O2. But we have to do the decomposition of these many moles of H2O2. So after that, I'll be using the unitary method basically. Nothing else. So remember this sort of a question as well. Okay, remember this sort of a question as well. I believe it's clear. I believe it's clear. Okay. One more question. Look at this properly. One more question. Look at this properly. Look at this question, guys. Look at this question. Standard enthalpy of vaporization of water at 100 degree is 40.66. The internal energy of vaporization of water. So first of all, as per the question, we are vaporizing water. That means H2O liquid, we are converting into H2O gas. This is the process. This is the process, right? As far as the question is concerned, delta H vaporization is given to me. How much? 40.66 kilojoules. Delta H vaporization is given to me as 40.66 kilojoules per mole. What do I have to calculate? I have to calculate internal energy change during the same process. I have to calculate delta U. First of all, what is the relation between delta H and delta U? You must have heard about this result. Delta H is equal to delta U plus delta NGRT, right? So what I have to calculate? I have to calculate delta U. Delta U has to be equal to delta H minus delta NGRT. Okay. I have to calculate delta U in kilojoules. That means delta H has to be in kilojoules, which is 40.66 kilojoules. Okay. Minus. What is delta Ng for the reaction? That's 1. R value I'm using as 8.314 joules per Kelvin per mole. Temperature is given to me as 100 degree. That means 373 Kelvin. Now, since I've taken the value of R as 8.314 joules per Kelvin per mole, so this particular term will be in joules. So I have to divide it with 1000 so that this term also comes in kilojoules. Perfect. So delta U is this minus this. Now, again, a matter of calculation. When you solve this, my dear students, the value is going to come as 37.5 kilojoules. So what is this 37.5 kilojoules? It is the value of delta U for the process. It is the value of delta U for the process which we were supposed to calculate. This sort of a question is asked. Okay? This sort of a question is asked frequently. And be careful with this question as well. Okay. Look at this one. Look at this one, guys. What about it? What about this question? As far as the question is concerned, 1 mole of non-ideal gas, 1 mole of non-ideal gas undergoes a change in state, from when the gas was present at initial state, pressure was 2 atm, volume was 3 liters, and temperature was 95 Kelvin. Now, the system is undergoing change in state. Final pressure of the system is 4 atm, final volume is 5 liters, final temperature is 245 Kelvin. Okay, this was your P1, this was V1, this was T1. This is P2, this is V2, this is T2. When the system is undergoing the change in state, pressure of the system is changing, volume of the system is also changing, temperature of the system is also changing. Right? So, whenever you get this scenario, wherein pressure as well as volume both will be changing, at that point of time, delta H is equal to delta U plus P2 V2 minus P1 V1. This is the result between delta H and delta U when pressure as well as volume both would be changing. Okay. Now, as per the question, delta U is given to me as 30 atm liter plus P2 multiplied by V2, 5 4s are 20, minus P1 multiplied by V1, 3 2s are 6. So 30 plus 14 comes out to be 44 atm liter. This is the value of delta U, delta H for the process which you were supposed to calculate. I believe, again, it's clear to everyone. Right? I believe it's clear to everyone again. Perfect, guys. Is it all clear? So the correct answer of this particular question is going to be 44. That's option C. Look at this question as well. Look at this particular question as well. As per the question, 5 moles of N2H4 undergoes complete decomposition at 27 degrees centigrade. Calculate the work done. First of all, how do we calculate work done? I gave you a result few minutes back only. W is equal to minus delta Ng RT. What is the value of delta Ng for this reaction? Delta Ng is number of moles of gaseous products, which is 4 plus 1, 5. Minus there is no gaseous reactant. So delta Ng is 5. So how do I calculate W here? Minus delta Ng. R value, since answer is in calories. So let me take the value of R in calories. Temperature is given to me as 27 degrees centigrade. That means 300 Kelvin. So this particular value comes out to be 3000 calories. But my dear students, this is the value of W for the decomposition of 3 moles of N2H4. When we do the decomposition of 3 moles of N2H4, the W value comes out to be minus 3000. W value comes out to be minus 3000. Therefore, when I do the decomposition of 1 mole of N2H4, W value will be minus 3000 divided by 3 calories. But as per the question, are we doing the decomposition of 1 mole of N2H4 or 5 moles? We are doing the decomposition of 5 moles of N2H4. And when we do the decomposition of 5 moles of N2H4, the value of W has to be multiplied by 5. So the final answer is going to be minus 5000 calories. This is the value of W which I was supposed to calculate. Okay. So again, I'm repeating the same thing. Be careful with these things. Be careful with these things, my dear students. Perfect, guys. That's great, guys. I'll keep on coming with those sessions as well. Those 40 marks in 15 minutes, 20 marks in 15 minutes. Don't worry. I'll come up with those sort of sessions more frequently. More frequently. Don't worry. Okay. Chalo, let's move on. Let's move on to another set of questions. Let's move on to another set of questions. Tell me first of all the answer of this question. Think over it and tell me the answer. Think over this question and tell me the answer. Quick. Adiabatic expansion of an ideal gas. First of all, in case of adiabatic processes, Q value is 0. Q value is 0. Now we use the first law. Delta U is equal to W. Since Q is 0. Since we are talking about expansion, in case of expansion, W value is negative. W value is negative. If W is negative, delta U has to be negative. Delta U means NCV T2 minus T1. This term is negative. This term can be only negative if T2 is less than T1. What does that mean? That means when the ideal gas undergoes adiabatic expansion, temperature of the system, does it decrease or increase? Temperature of the system decreases. Temperature of the system decreases. And you know, temperature and internal energy, they are directly proportional. Temperature decreasing means internal energy of the system decreasing, right? So the answer of this particular question has to be option 1. Answer of this particular question has to be option 1. Okay? I hope I'm clear with this as well. I hope I'm clear with this particular question as well. Perfect. Since delta U is negative, delta U negative only means internal energy of the system is decreasing. Tell me the answer of this one. Tell me the answer of this one, everybody. Everybody in the chats. Everybody in the chats. In case of cyclic process, first of all, you should know in case of cyclic process, change in the value of any state function is 0. Change in the value of any state function is 0. Enthalpy is a state function, its change will be 0. Internal energy state function, its change will be 0. Gibbs free energy is a state function, its change will be 0. Work done is not 0 in case of cyclic process, right? In case of cyclic process, magnitude of work is basically equal to area enclosed by the loop. Area enclosed by the loop. Okay, in case of cyclic process. You should know this. You should know this. You should know this, people. Just a second, guys. Let me call HSP sir. I hope he's ready. Just a second. Let me see if he's... Because right after me, it's going to be HSP sir's turn. Sir, kahan ho? Studio में ही हो ना? 10-15 मिनट में हो? Because I feel tired a bit. ठीक है? Okay. मैं कॉल करूँगा वापस उस टाइम पर. Okay, sir. Okay, look at this question. Look at this question, guys. We are given the cyclic process. In case of cyclic process, what do we have to calculate? We have to calculate the value of QAB and QCA. QAB and QCA. QAB. During the process AB, what is remaining constant? Volume is remaining constant. So we have to calculate heat absorbed or released by the system at constant volume. QAB is basically heat absorbed or released by the system at constant volume. That will be NCV delta T, T2 minus T. What is N value? Number of moles. 1 mole of ideal, 1 mole of ideal gas. The ideal gas is monoatomic in nature. Its CV has to be 3/2R. 3/2R. T2 minus T1. A to B. T2 is 600. T1 is 300. So the value comes out to be 300. So this value, this is 1. This is 1. This is 150. So the value comes out to be 450R. So QAB I got as 450 R. QAB I got as 450 R. Now what about QCA? If you talk about the process CA, during the process C to A, pressure remains constant. So we have to calculate heat absorbed or released by the system at constant pressure. And heat absorbed or released by the system at constant pressure is nothing but NCP delta T. NCP T2 minus T1. What is N value? That's 1. CP for monatomic gas, 5 by 2R. T2 minus T1. This is final temperature, this is initial. So final minus initial will be minus 150, right? It's going to be minus 375 R. So Q value here comes out to be minus 375 R. So it's option C that has to be the correct answer of the question. Option C that has to be the correct answer of the question. Okay? I hope these sort of questions you can solve easily. In which of the following entropy change is negative? In which of the following entropy change is negative? Whenever there is evaporation of water, whenever liquid gets converted into gas, whenever H2O liquid gets converted into H2O gas, what happens to entropy? Does it increase or decrease? What happens to entropy? Does it increase or decrease? Entropy increases. So delta S here is positive. Delta S here is positive because H2O liquid is getting converted into H2O gas. So if liquid is getting converted into gas, that means entropy definitely, randomness, disorderness is increasing. Okay. Now, if you directly go into the last option, look at the last option, guys. This is 2 times H gas. It gives us H2 gas. It gives us H2 gas. So here the coefficient is 2, here the coefficient is 1. So when this process is happening, number of moles are decreasing. If number of moles are decreasing, that means particles are decreasing. If particles are decreasing, disorderness, randomness will be decreasing. And disorderness, randomness decreasing means entropy is decreasing. Entropy decreasing means delta S negative. Right? Delta S negative. Perfect. Perfect, people. I hope this is clear. I hope this is clear. In which of the following entropy change is negative? Entropy change is negative. If I look at the first question, synthesis of ammonia from N2 and H2. So it is N2 gas plus 3 times H2 gas. What do they form? They form 2 times NH3 gas. So during this process, is entropy increasing or decreasing? Check it out. Check it out, guys. So on reactant side, we have 3 plus 1, 4 moles. On product side, we have got 2 moles. So are the moles increasing or decreasing? So during the process, moles are decreasing. And if moles are decreasing, what does that mean? That means if gaseous moles are decreasing, that means disorderness, randomness will be decreasing. And if randomness is decreasing, entropy decreasing. Entropy decreasing means delta S negative. Delta S negative. I hope this is clear. I hope this is clear. If entropy is the only criteria for spontaneity, remember, then for the process to be spontaneous, delta S total has to be greater than 0. This is the criteria for spontaneity. If entropy is the only criteria for spontaneity, then for any spontaneous process, delta S total has to be greater than 0. What is delta S total? Delta S total means delta S system plus delta S surrounding. So delta S system plus delta S surrounding has to be greater than 0. Then only I can say your process is spontaneous. Okay, remember this particular point as well. This can be asked. This can be asked. Tell me the answer of this question. Well, it's a P by Q, but these sort of questions are frequently asked. I'm giving the reaction 2 times Cl gas. It gives Cl2 gas. It gives Cl2 gas. Okay. So first of all, 2 moles on this side, 1 mole on this side. Moles are decreasing, particles are decreasing, entropy decreasing, delta S negative. Delta S negative, right? Now, if you talk about this particular reaction, what is happening? We have got 2 chlorine atoms forming 1 chlorine molecule. So bond formation is taking place. Bond formation, is it endothermic or exothermic? Bond formation is exothermic. And for any exothermic process, delta H has to be negative. So delta H negative and delta S negative. Delta H negative as well as delta S negative. Okay? Since bond is being formed, bond formation is exothermic. For exothermic processes, delta H has to be negative. I hope this is also clear to everyone. As per the question, remember one more thing. This is again a frequently asked question. For any process to be spontaneous, delta G for the system at constant pressure temperature, it has to be negative. What is delta G? Delta G is basically delta H minus T delta S. This has to be negative for any process to be spontaneous. For any process to be spontaneous. Now, as per the question, delta H is given to me as 80 kilojoules. That means 80,000 joules minus T. Delta S is given to me as 2 times capital T. So it becomes 2T square. This has to be negative. So I would say 80,000 has to be less than 2T square. Just reverse it. I can say 2T square has to be greater than 80,000, which means that T square should be greater than 40,000. If T square is greater than 40,000, that means T has to be greater than 200 Kelvin. So I can say temperature has to be kept greater than 200 Kelvin. Temperature has to be kept greater than 200 Kelvin, then only the process is going to be what? Then only the process is going to be spontaneous. That's something which I was supposed to calculate. Okay? That's something which I was supposed to calculate. My dear students, now HSP sir is going to join in. I'm left with 4 chapters. One is equilibrium, okay, solution, kinetics, and electro. Let HSP sir complete, then we'll see the other chapters as well. Okay, HSP sir is going to do your organic chemistry as well as class 12th inorganic. HSP sir will be doing your class, your complete organic and class 12th inorganic. Perfect. Okay. So either I'll continue in the same stream today or I'll take one more session wherein I'll discuss these 4 remaining chapters as well. Perfect. Achha, one more thing, guys. I want to show this to you. One more thing. See, when you go to the playlist, I want you guys to watch few sessions which are really important. Go to the playlist. When you go to the playlist, this Game of NEET 2.0 is there, right? When you open this playlist, this is one session wherein I have solved some top 100 questions of mole concept. Number 1, first session. Number 2, top 100 questions of chemical bonding. This has to be watched by you. Number 3, top 100 questions of electrochemistry. Top 100 questions of electrochemistry. Top 100 questions of thermodynamics. And the session duration is just 1 hour, 1.5 hours. You can watch them at 2x speed. Okay? And similarly, top 100 questions of GOC. Top 100 questions of GOC. Do one thing, watch these sessions as well. Watch these sessions as well. Because they are going to be very effective for you. See, right now you cannot watch these particular sessions wherein I have completed one chapter in 10 hours. You don't have that much of time. Okay? You don't have that much of time. But these question practice sessions, I would want you guys to watch. I would definitely want you guys to watch these question practice sessions. These are very, very, very important, right? Let me call HSP sir. Let me see if he's ready. Just a second. सर मैं स्टॉप कर रहा हूँ, आप स्टार्ट करो. ओके.
Hey everyone, welcome, vanakkam, suswagatam. Kids, just to let me know, am I audible and visible to all of you? If yes, I want to see green hearts in the chat section. That's really awesome that everyone can hear me, can see me. And my dear students, we are over here with the best questions which are expected to be the score giving, the rank giving questions. So, if everyone is ready, I want to see fire in the chat section. As Wassim Sir, the Thalaiva, he has taken the best session, the best questions. I was just in the studio and watching this lecture, really fabulous lecture. And by seeing his video, even I feel accomplished. And you kids really performing very good. Your stupendous performance is really giving me that sense that you are going to perform the best in your coming examination. So, I can see really the fire along with green hearts, and I will not take much time of yours, but whatever is required definitely to give the best. Yeah. Now my dear students, meanwhile I was in the studio and I have made 2 mind maps also for you. Definitely you will get tomorrow, and one you will get tomorrow and one after, yes, 1 or 2 days. So are you ready? Yeah, here is the question. First question, sit with pen and copy, give positive marks if the answer is correct, otherwise give negative marks. Let me see in the chat section how many of you are there. Yeah, I can see Yashwant Reddy, Tia Agrawal, Rupanshi, Sarika, Tarun. Now my dear friends, hit the like button if you're new. Yeah, Power, Dayara, BMW word, that's really Pooja, Iram. Wow, that's really awesome. That's really awesome. So here is the first question on your screen. Devi और सज्जनों, भाई और बहनों, this is KBC. Glitch is there. So one student is writing glitch is there. I think everything is fit and fine. Vishal MH, once again do let me know, write down in the chat section that my voice is clear, kids. Lemo Leaf, Raystar, everyone just to let me know. Welcome, Vanakkam, Suswagatam. Yes, everyone. Yeah, PDF I am sharing continuously, but do let me know my voice is perfect. Yashwant Reddy, that's really awesome. Now, first question over here. So let me move. Incorrect method of preparation. Remember that whenever the question is going to be like this, always remember that what they are talking about. They are talking about incorrect. So take care. You should have eagle eyes on this. First of all, you should have eagle eyes. Read out question properly and fast. Write down the answer. Incorrect method of preparation of alcohols from the following. I want to see the correct answer in the chat section. Chat should run very fastly. Yeah, that's really awesome. So reaction of preparation of alcohols from the following. Reaction of ketone with RMGX. Definitely this is correct. Why? All ketones on reaction with any Grignard reagent R dash MgX, zinc and water, what do you get? This R negative and this carbonyl positive, bring this R over here, what do you will get? You will get R, C, O. Now see just how to form any alcohol from Grignard reagent. Add this Grignard reagent's negative part over here and H over here. So you can get primary alcohol, you can get secondary alcohol, you will get tertiary alcohol. So this is correct. This is true. It's not incorrect. It's true. Reaction of alkyl halide with aqueous ONH. It's very simple that Rx plus NaOH. This NaX will eliminate out. You will get alcohol Hydroboration, this is the reaction of class 11th, that R CH double bond CH2 plus HBO, you will get R CH2 CH2 OH. Ozonolysis of alkene. My dear students, if you do ozonolysis of alkene, then it will give you aldehyde or ketone. Simply you break it from here, you will get R C double bond O. So this is your answer, because this is wrong, this is false. So this is the correct answer. How many of you got the correct answer? Do let me know in the chat section. Show green hearts if your answer went wrong, fire, otherwise green hearts. Yes, 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 kids. If your answer is correct, green hearts. If it's wrong, then fire, fire. Yes, kids, yes. That's really awesome. Now, I'm here with another question. Question number 2. And this is the explanation given over there. Now, let's move with another question. The correct IUPAC name of the following compound. This is your compound. You are supposed to find out the correct IUPAC name. Now, see. What should be the answer? This is alcohol, this is Br, this is Cl. This is senior most. This is your senior most. So numbering should be done in such a way that the senior most functional group should come earlier. Now see, 1, 2, 3, 4. 1, 2, 3. So 1, 2, 3, 4, 5. And 6. So on 5 it is chloro, 1 bromo, 1 bromo, 5 chloro, 4 methyl, and hexane triol. Hexane triol, where it is given 1 bromo, 6 bromo. Wrong, 6 bromo, wrong, 1 bromo, 1 bromo. Chloro is at 5, chloro is at 5, chloro is at 4, methyl, chloro will come first alphabetical wise. So D is the answer, and let me check it out. D is the correct answer. How many of you got it? Really? Full marks, green hearts, kids. Heart should be there or fire should be there. If you are getting correct answer, then the green hearts. If you are getting wrong answer, then the fire, because in the chats I want to see the Josh. If it is that is missing, then it's useless, kids. If you're not having full energy, if you're not that having full enthusiasm, so if you're not ready to do the question, that is useless. Very good. Now it's fantastic. Now another question. Benzene reacts with methyl chloride in presence of anhydride. So it's very simple. So anyone can give the answer with methyl chloride. So definitely toluene is going to be the answer, and it's really simple question. Now I'm going to give you one tough question from my side. Are you ready? From my side, you want one question from my side? Let's set go. Yes, any compound from public side. What compound you are going to give? I will start from there. Let me see in the chat section. Any compound. You give me any compound, I will start with that. Write down. Any compound. Let's see whatever the compound is coming first. I will make question from there. Yes, kids. Everyone just do let me know in the chat section. Toluene. Okay, let's go with the toluene. Just see, I'm going to frame out the question from toluene. One kid said, make question from toluene. Cl2 H nu A Cl2 350 degrees Celsius B KOH aqueous in excess C heat D CrO2, Cl2, CCl4, H3O plus, E, CH3, CH double bond O, dilute NaOH, heat, F. So let's see, I will not give the options. What is F? I want to see the answer in the chats. What's being F? I will not give the options. Let me see who is going to give the correct answer, kids. Till now no one, till now no one. Till now no one, kids. Till now no one has given the answer. Yes, kids. Prajwal Reddy, answer is wrong. Prajwal Reddy, your answer is wrong. Yeah, Gautam, yes, Gautam, I remember. I do remember, but kids, do let me know what's the answer. Fast, fast, kids, fast. Let me see who is going to give the correct answer, kids. No, till now, no one has given the correct answer, kids. Okay, now see your revision. Your revision is not up to the mark. Your revision is not up to the mark. Just see. Just see, kids. Toluene FRSR, free radical substitution reaction. You will get benzyl chloride. Benzyl chloride. Now, once again, FRSR, free radical substitution reaction, you will get benzyl chloride. CH, Cl, Cl, 2 times KOH. So, K positive, OH negative. This will eliminate out K positive, OH negative, eliminate out. This CH, OH, OH. Now, remember that 2 hydroxyl groups on 1 carbon are not stable, so water will eliminate out. On heating, water will eliminate out. What do you get? You will get benzaldehyde. Benzaldehyde. Now, so this CrO2Cl2 will not do any reaction because this CrO2Cl2 converts toluene to benzaldehyde. Already it is benzaldehyde, so no reaction. No reaction. No reaction. This is already benzaldehyde. This is also benzaldehyde. Both of them are benzaldehyde, and this is Claisen-Schmidt reaction. Claisen-Schmidt reaction is CH double bond CH double bond O, aldol condensation, water will eliminate out, and your answer is cinnamoldehyde. Cinnamoldehyde. Claisen-Schmidt, you can say this reaction's name is Claisen-Schmidt, or you can call it what? You can call it cross aldol condensation. So everyone got failed? Everyone? Or if is there anyone who got full marks, then show green hearts, and those who got failed, the fire. I want to see fire, kids. Now if you want one more question of this type, you can write down yes, 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 and if you want printed question, then printed. Let's see what you want. If you want such type of question, then yes, 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 otherwise printed. Okay, yes, yes, yes. So let me give you another question. Now, let me start. Calcium carbide. Calcium carbide, water is giving out A reacting with NaNH2 excess giving out B. B is reacting with Br CH2 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 Br giving out C. C reacted with H2 PD, C giving out D. D is undergoing reductive ozonolysis O3, zinc and water giving out E. E has been treated with dilute NaOH, heat giving out F. Now, what is the IUPAC name of F? IUPAC name of F. That's my question. Let's see who is going to give the correct answer. Everyone, the question is in your court. Yes, yes, yes. Kids, fast. Let me see what answer you are going to give and who is going to give the correct answer, kids. Fast, kids, fast. No, till now no one has given the correct answer. Till now no one has given the correct answer, kids. Neither self-Eldor nor Cannizzaro reaction. Till now. Okay. So, I'm here to give the correct answer. Just see, you can check your answer, everyone. See, kids. Calcium carbide plus water. Calcium carbide, just see to it. Negative charge, so it will react with water. HOH, del plus H, del plus OH negative. So this is acetylene. So this is, here it is acetylene, CH, triple bond CH. It is having two acidic hydrogens. So NaNH2 will react. How it will react? Acidic hydrogens. So NH2 negative will come. It will take away proton, ammonia. Here also NH2 negative will come. Proton. Now sodium will remain over there. Sodium will remain over there. So you will get disodium acetylide. NaC triple bond CNA. Now see, my dear students, how it is going to react. This NaBr will eliminate out here and this NaBr will eliminate out from here. What you will get? Cyclohexane. You are going to get cyclohexane kits like this. Now, this is a Linde-Larz catalyst. Linde-Larz catalyst. So, this is cyclohexene now. And cyclohexene will undergo reductive ozonolysis. This is your reductive ozonolysis, my dear students. Ozonolysis. So, you will get CH double bond O, CH2, 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 CH2 and CH double bond O. Now this is best example of intramolecular aldol condensation. Intramolecular aldol condensation, just remove water and your product will be this one. Just see to it, my dear students. Very, very important. Now the thing is that once you have written the product, your turn is to write down the IUPAC. Let's see how many of you can write down the IUPAC for this. 1, 2, 3, 4, 5. So, cyclopent 1-ene carbaldehyde. This is known as chemical abstract name. How many of you got it? If you are able to understand, I want to see green hearts. Everyone. Now, I will give you printed question once it's clear, because I know that you won't be able to do such type of questions. You are not able to do such type of questions. So let's give printed question, or should I frame out one puzzle question? Should I frame out some puzzle question, or you want to go with printed question? Puzzle question, printed question, puzzle, printed. Just to let me know in the chat what type of question do you want to have, puzzle or puzzle question or puzzle. Okay, printed puzzle, printed puzzle. First printed then puzzle. Okay, first printed then puzzle. Here is question. The amine that reacts with Heisenberg's reagent to give an alkali insoluble product is. To give an alkali insoluble product. Just read it out properly. First thing is that it is giving out Heisenberg. It is reacting with Heisenberg reagent. But what they are talking about? They are talking about that is insoluble, alkali insoluble product. So what answer you are going to? Yes, let's see what answer. Let me check it out in the chat section. What answer you are giving? Everyone, do let me know in the chat second. Some are going with C. Kids, do let me know quick. So remember that this is indicating the amine that reacts with Heisenberg reagent. That means can't be 3 degree. It can't be 3 degree. Now either it is 1 degree or it is 2 degree. Now remember that if it would have been 1 degree, then it must have reacted with Heisenberg reagent. What is Heisenberg reagent? Benzene sulfonyl chloride. It must have reacted with this, and whatever the product would have been formed, it must be having one acidic hydrogen. That must be having one acidic hydrogen, kids. And that acidic hydrogen says that if you are going to react with NaOH, it must be soluble. It would have been soluble, but what they are saying, alkali insoluble, so it is not 1 degree also. So what is left? Only the answer is 2 degree. Now let's see who is 2 degree. It is NH2, so it is 1 degree. Here 2 degree. Here 3 degree. Here 1 degree. So what's the answer? Answer is second. Let's see, kids. Yay! Even Baba is solving question. Even I'm also solving question with you, along with you, kids. Now, next question. Consider the following reaction and find the product A. It's very simple. A Rosenmund reaction. Anyone can solve it. Rosenmund reaction. But what happens in Rosenmund? COCl will convert into CHO. That means your answer is benzaldehyde. Benzaldehyde A first. Right? Next question. This is a bit tough question. Let's see who is going to give the correct answer in the chats. Let me check it out. Who is going to give the correct answer in the chats? Fast, kids, fast. Everyone, let's see how much score you are going to get, kids. Everyone. Some are going with 2, some are going with 3. What is this? B or A? Everyone, let me see in the chat. Let me also solve it. See, kids, see. This is remaining like this. This is remaining like this. There is no change. There is no change. This is washed away. This is washed away, and this can be done only by redox reaction. Redox, remember that. Now what can be used? The mild reducing agent. Either you can use H3PO2, or you can use glucose to remove it, or you can use SnCl2, or you can use ethyl alcohol. Out of these 4, anything can be used. So let's see what they have given. phosphinic acid. So this can't be the answer, this can't be the answer, this can't be the answer. On the second is the correct answer, and its name is phosphinic acid. Remember that, phosphinic acid. Now some people must be thinking, why ick? It should be us. This is the general name, right? Otherwise hypophosphorus acid. I hope that it's clear to each and everyone. Now let's see. Hey, second is the answer. Now another question. This is really a little bit tough question. Let's see who is going to give the correct answer in the chats. Everyone, just to let me know. Fast, kids, fast. I want to see, is there anyone who is going to give the correct answer? Hey, everyone, let me check it out. Some are going with 4. Okay, Baba HSP, you also try it out. Baba HSP. La, how to solve it? Just see. You are benzene disonium chloride. La, N double bond N. Now you are aniline. Your H will go away with chloride. Your H will go away with chloride. It's chloride and your H will go away. NH2 will remain over here. So what should be the answer? It's. Why I am using this much of yellow color? What happened with me? Why I am using so much of yellow color, kids? Why, kids? Now remember that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and these many delocalized electron. Yellow dye. Para-amino-azobenzene. What is the name of this compound, kids? Para-amino-azobenzene. Everyone understood? So where it's given? 4th is the correct answer. Same. Yeah, now another question. Lucas reagent. This though everyone can answer it. Lucas reagent is equimolar solution of anhydrous ZnCl2 plus concentrated HCl. So anyone can answer it? No, I have given even a bit more. Concentrated Zn. Oh, hydrous. Oh, wrong, Baba, wrong. Sorry. Concentrated, wrong. Now, equimolar concentrated HCl anhydrous ZnCl2. This is the correct answer. My God, such anaconda type of options are given over there. Very tough options. Very good. HSP, you have done it. Clemenson's reduction of ketone is carried out in presence of which of the following? So everyone knows the answer. Zinc HgHCl. Very simple. Which of the following reaction will not result in the formation of carbon-carbon? Tough question. Let me tell you, kids. Be aware of such type of questions. Awesome question. Really awesome, fantastic, fantabulous question. And you need to have knowledge for this. Let me see who is having knowledge, who is going to give the correct answer. Let me see in the chats. Oh my God, Harshpreet B, Navodaya 2, Jyoti 4, Harshpreet B. Okay, everyone is going. So, Canijaro, oh my God, yes, Reamer-Teamer carbon-carbon bond is there. You are so intelligent. Woods reaction, carbon-carbon, new bond is there. Friedel-Crafts, carbon. Kids, you are genius. So, now go back to your home. Yes, no carbon-carbon new bond formation. It's really, you are awesome. You are more intelligent than Baba HSP. Even I cannot solve in this much of time. You have done really superb performance, kids. Really, Nalla Iruku. You are Romba Sulbam, making it Romba Sulbam. Kids, I'm taking more time to solve these questions. You are solving it immediately. So you're better than me. Another question. In the following reaction X, where is X? There is X. And this is, oh, class 11th. Class 11th NCERT. Do you remember class 11th NCERT? Hydrocarbon. Hydrocarbon. This is isomerization. Isomerization. So this is wrong. This I think this is the correct. Cl2 will not be there. Wrong, wrong, wrong. I will go with 1. Let me check it out. How many are with me? How many of you are with me? B. You are going with B. It's how B? How B? Isomerization takes place. Aromatization takes place. CrO3 in the presence of CrO3. I don't think. I will go with 1. Yeah. Yes. Everyone was going with B. Baba HSP said it's 1. Gets? Let me check it out in the chat section. What I said. Kids, you got failed or not? You got failed or not? Just to let me know you got failed or not. B is not aromatization. That is not aromatic. This is not. This is simply cyclohexane. No such type of reaction is there in NCERT. Either isomerization or aromatization. Aromatization takes place in the presence of V2O5. Aromatization, check it out. Aromatization will be in presence of what? In presence of Cr2O3, V2O5, like that. And even this is not aromatic. It's not aromatic, right? Got it, kids, or not? You understood or not? Did you understand or not? Have you understood or not? Do let me know. If yes, show me green hearts. Hey kids, do let me know that you are able to understand or not. Show me green hearts if you got it, if it is clear. Hey kids, Baba will start crying. My dear student, no response. Once if you are able to understand, it's your duty, it's your moral duty. Kids, we are giving you the best time. It's night time. Even we are awake. Hey, wow, great. Now, what is this? It is physical chemistry. So, Wassim sir will take care of it. Inorganic, a little bit. Organic questions will come. After inorganic, class 12th organic will come. Are you comfortable with inorganic questions? If yes, I want to see some fire in the chat section. If you're comfortable with inorganic questions, I want to see some fire in the chat section. Okay, good. That's fantastic. Here is first question. The correct order of increasing ionic radii. Let me check it out, the answer in the chats. What's your response? Very good, Adhira. Yes. Shirisha is going with A. Some are going with 4. A4. Let me see whether A or 4 is going to be the correct answer. Let's see. First of all, you should have knowledge of isoelectronic entity. If I write down magnesium 2 plus, how many electrons? 10 electrons. If I write down sodium plus, how many electrons? 10 electrons. Fluorine negative, how many electrons? 10 electrons. O2 negative, how many electrons? 10 electrons. That means all they are having same number of filled orbits. Now, who is having least effective nuclear charge? See, nitrogen, N3 negative. Maximum repulsion will be there. Force of repulsion is maximum and force of attraction is minimum. So, its radii is maximum. So, the radii will be in this order, anaconda order. N3, O2, F, Na plus. So, the correct answer is first. Everyone got it? Everyone got it? So, I can say the radii for isoelectronic entities directly proportional to negative charge and inversely proportional to positive charge. Right, kids? Yes, sir. Oh, it's written over here. Sorry, already written over there, right? Next question. The dipole moment is minimum in. The dipole moment is minimum in. Let me see in the chats. What's your answer? Dipole moment is minimum in. Everyone just to let me know. Dipole moment is minimum in D. Okay, let me see. BF3 is 0. Boron, fluorine, fluorine, fluorine. Just see, if I talk about this vector and this vector, cancellation will be by this vector. So it will 0, 0, 0, right, correct answer. Which pair of molecules does not have identical structure? It's a time-taking question. Just try to do it. It's a time-taking question. Let's see who can do it immediately. I'm over here waiting for your answer, kids. Some are going with D. Let me check it out. A. Some are going with A. C is also clicked. All the options are clicked. Kids, all the options got clicked. Now see, if I talk about I3, how to do it? Just calculate a steric number. Once steric number is clear, find out hybridization. Once hybridization is clear, find out electronic geometry. Electronic geometry is clear, find out shape. Agreed or not? This is the order. Now, I3 negative. Central metal atom I negative with I and I. It is already having 7 electrons, 8 electrons. So 1, 2. How many are left? 6. So 1, 2, 1, 2, 1, 2. 3 lone pair and 2 sigma bond. So steric number is sigma bonds plus number of lone pairs localized. So 2 plus 3 is coming out 5. 5 means electronic geometry for this is trigonal bipyramidal. So its shape will be I, and I. Linear shape. It is linear. This is also linear. So both of them are being linear. Which pair of molecule does not have identical? Both are linear. So this can't be the answer. Are you getting my point? Now who is left, kids? Who is left? Which will you call as the answer? This is BF3. This is ICl3. Now this is the way I have told you. Now find out what should be the correct answer. Who is going to tell me the answer? Yes, who is going to tell me the correct answer? I have told you each and everything how to do it. Kids, do let me know. Some are going with B, some are going with C. Do let me know. B or C, kids. B or C, do let me know, kids. Okay, same. C, BF3. Boron is trigonal planar. trigonal planar, because 1 sigma, 1 sigma, 1 sigma, steric number is 3, sp2 hybridized trigonal planar, right? Now ICl3, iodine is having in the balance shell 1, 2, 3, 4, 5, 6, 7, 6, 7, and Cl, one Cl, one more Cl, one more Cl. So steric number is coming out 3 sigma 1, 1, 2, 3. 3 plus 2 is coming out 5. 5 means, yes, now it's 5 means trigonal bipyramidal, and remember that in trigonal bipyramidal the lone pair occupies equatorial position. So equatorial position means I and 2 lone pairs will come over here on the equatorial position. Now 1 Cl will come over here, 1 Cl will come over here, 1 Cl. So slightly bent because of lone pair. So little bit bent, I will say bent T shape. Bent T shape will be the shape, bent T shape, and this is trigonal planar. So their structures are different structures. Got it, kids? If yes, I want to see green hearts. If really you got it, I want to see in the chat section green hearts. Kids, do let me know if the explanation is clear, each and everything you got it. Kids, do let me know in the chat section. Hemlata is asking, explain once again. Okay, let me tell you. BF3 and ICl3. Let me explain. BF3 and ICl3. BF3 and ICl3. Let me rub it. See, Hemlata. First of all, what you are supposed to do, find out steric number. How to find out steric number? Number of sigma 1 plus number of lone pairs localized, right? BF3, boron, atomic number is 5 and 2, 3. So outermost is having 3 electrons, 1, 2, 3. So fluorine is having 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. Form the bond, fluorine. Form the bond, fluorine. Form the bond. Now boron, central atom is boron. So its steric number is 3 sigma 1 plus 0 lone pair, no lone pair, 3. So it is sp2. So shape will be trigonal planar. Trigonal planar. This point is clear. Trigonal planar. Now see this ICl3. Everyone just see ICl3. Iodine belongs to halogen family. Halogen means 7 electrons. 1, 2, 3, 4, 5, 6, 7. Now Cl3. Cl3 means 1 chlorine, 2 chlorine, 3 chlorine. So how many sigma bonds? 1, 2, 3. How many lone pairs are left? 2. So steric number is 3 plus 2, that is 5. So 5, the hybridization will be sp3d. sp3d means trigonal bipyramidal. How it looks like trigonal bipyramidal? If I write down PCl5, then PCl, Cl, Cl, and 1 Cl above the plane, 1 Cl below the plane. This Cl is equatorial, this Cl is equatorial, this Cl is equatorial, and they are being axial. So remember that if any compound is having lone pair or pi bonds, they will occupy equatorial position. I hope it's clear. So the lone pair, they are occupying equatorial position. 2 lone pairs are occupying equatorial, and the sigma bonds, they are giving shape. Remember that shape is given by sigma bonds. Pi bonds and lone pair, they never give shape. They only destroy the shape. Now clear? Let me see in the chat section. Kids, Now do let me know if my explanation is really awesome. If you are able to understand, kids, at least show me some green hearts. If you really liked it, kids. Next question. Which one of the following ions exhibit DD transition? For DD transition, what is required? For DD transition, what is being required? At least one unpaired electron is required. So CrO4 negative. Chromium belongs to which group? Science teacher, very crazy man. Felt cold in night with cousin. Atomic number of chromium 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So chromium is over here 24. Chromium 24. Now 24. So I will write down chromium 3d5 4s1. Doesn't follow the rules. Now chromium's oxidation state. Just now sir has taught you chromium x plus 4 into minus 2 is equal to minus 2. So x minus 8 is equal to minus 2. So x is equal to how much? 6. So if all the electrons have gone, 6 oxidation state. So 3d will be 0, 4s will be 0. So it is not having any electron unpaired. This is also n is equal to 0 because plus 6 plus 6. MnO4 2 negative, MnO4 plus 7. Manganese, all the 7 has gone. Its n value is 0 and its n value is 1. So this should be the correct answer. But all those 3 are also colored. What I'm talking about. CrO4 negative, CrO4 2 negative is yellow colored. Now Cr2O7, Cr2O7 2 negative is orange colored and MnO4 negative is pink. Now what's the reason? They are also colored. Without any unpaired electron, they are colored. Without unpaired electron, without having unpaired electron, they are still colored. They are still colored. Why and how? They are still colored. Do let me know in the chat section. Let's see who is going to give the correct answer. They are still colored. Anyone from the media, from the chat section, public section, kids, do let me know. Anyone, is there anyone who can answer it? They are still colored. And the color, no one is able to give the correct answer due to charge transfer spectra. Their color is due to charge transfer spectra. Charge transfer spectra. It's given in your NCERT class 12th DNF block. DNF block. Remember that. You are really liking the explanation, then do let me know. Show me green hearts if you really like the explanation, kids. Kids, you are not participating due to charge transfer. Yes, Rupanshi, but everyone, do let me know, kids. Fast. I want to see you answer that you are still liking it or not. Whatever, green hearts. Very good. Now another question. So I have told you it's like that only. Now next question on your screen. Another question on your screen, kids. Very good, Adhira. Fantastic. Do let me know, kids. Yes. Okay, now let me check it out. Kids. Identify wrongly matched ammonia trigonal pyramidal. It's pyramidal. Okay, PCl5 trigonal planar. This is wrong. Why? This is wrong. Why? PCl5, if you check it out, phosphorus is atomic number 15. 2, 8, 5. So it is having 5 electrons in the outermost shell. 1, 2, 3, 4, 5. So chlorine is having 7 electrons in the outermost valence shell. So 8, chlorine 8, chlorine 8, chlorine 8, chlorine 8. Now how many sigma bonds are there? 1, 2, 3, 4, 5 sigmas. So steric number is 5. 5 means I can write down sp2 plus pd, or I can write down sp3d, whatever. Now see, phosphorus over here, 3 chlorine, they are forming equatorial bond and they are remaining at 120 bond angle. Equatorial. Now 2 chlorines, they are far away, that it is axial, and it is being axial like this. Trigonal bipyramidal. Its shape is trigonal bipyramidal. This is the shape, right? Got it? So this should be the answer. Yeah. Now kids, which is the following reaction is correct? So you have to cram it, you should know it, and it's the answer. Now once again, physical chemistry question, Wassim Sir will explain. Now kids, let me take some more organic questions. 10 to 15 minutes more. Are you ready for that? Only 10 to 15 minutes more I will take, and then it will be over. Kids, do let me know, are you ready? If yes, I want to see fire in the chat section. 10 to 15 minutes more, kids. Vishal MH, very good. Kids, do let me know, are you ready? Kids, what happened? No green hearts, no fire. What's going on, kids? Prajwal ready, very good. Vishal, just no break, only 10 to 15 minutes more. The session is for 10 to 15. That questions will get completed, so no need of break, kids. Let's move fast. Reaction of propanamide with this, very important reaction. Propanamide, just see everyone. Propanamide, CH3, CH3, CH2, CONH2, propanamide, Br2KOH, cover. Br2KOH will produce cover. Now in this condition, this CO will eliminate out and you will get 1 carbon less primary amine. So I always sing one song for this. Primary amide has been treated with the cover. We got primary amine with 1 carbon stolen. What I said? Primary amide has been treated with cover. We got primary amine with 1 carbon stolen. That means it was having 3 carbons and that is having just 2 carbons. So 1 carbon is being stolen. So answer will be ethylamine. Third. Agreed? Everyone agreed or not? This reaction is very important. Everyone just do let me know, are you able to understand or not, kids? Yes, Prajwal ready? Sir, thank you. Yashu, thank you. Now let me tell you what are the intermediates from this reaction. During this reaction, these intermediates are very important. This reaction will proceed like this. This reaction, first bromamide, CH3, CH2, CO, NHBr. Remember that. Then anion of bromamide, then CH3, CH2, CON, nitrene. After nitrene, isocyanate, C2H5, N double bond C double bond O, isocyanate. Then carbamic acid, C2H5NH, C double bond OOH. These are the intermediates. Remember the names. It is bromamide. It is nitrene, acyl nitrene. This is isocyanate. This is carbamic acid. Got it, kids? Got it? Now, next question. Lucas test is used for determination of. Definitely, it's very simple. Alcohols. Tertiary alcohol gives turbidity immediately, right? Within fraction of seconds. Secondary alcohol gives turbidity after 5 minutes. Primary alcohol after a long period of time. Turbidity right, kids? Right. Now, let's see who is going to get the correct answer for this question. Everyone, fast. I'm waiting for your answer. Yes, kids. Fast. D. Okay, let me. Yeah, that's super awesome question. And the correct answer is you have given as you have given, kids. D is the correct answer. Pyridinium chlorochromate, because this is only at aldehyde and this is more mild oxidizing agent. What is PCC? Let me tell you. PCC, if you take pyridine is a base, HCl is an acid. Now acid and base cannot live like this, they will react together, and the ratio is 1:1. 1:1. Now who is the third one? Third one is CrO3. They all are in equimolar. Now base, this proton will come and attack on the lone pair of this. So pyridine will get converted into pyridinium. Pyridine will come, attack over here, pyridinium chlorochromate. Pyridinium chlorochromate will be the answer, right? Next question. Let me see who is going to get the correct answer, kids. Let's see the chats. Let me see the chat. Who is going to give the correct answer, kids? Fast, kids, fast. I'm waiting for your answer. Kids, quick. Very good, very good, really awesome. This reaction phenol, these together will produce what? They will produce dichlorocarbene, the actual attacking agent. And salicyldehyde will be the answer. This is major one. That is actually minor. So definitely this reaction's name is Riemer-Tiemann. Riemer-Tiemann reaction. Yes. Yes. Next question. Which of the following is most stable carbocation? So this anyone can tell the answer. Yes. Anyone. The simple question, super easy question. This is having 9 alpha hydrogen atom, so stabilized by hyperconjugation as well as stabilized by inductive effect. Its degree is 3 degrees. So this is the most stable. If you want to write down the order, then D, after D it's C, after C it's B, and after B it's A. This is the stability order. Am I right or wrong? Absolutely correct, sir. Next question. Let's see who is going to give the correct answer for this question. I'm waiting for your answer kits. Yes. Okay, let me check it out whose answer is being absolutely correct. Nitration of aniline is strongly acidic medium. Let me first of all tell me that this is aniline. Now if you want to do nitration, so you have to use H2SO4. Now this H2SO4 is strong acid. Now strong acids thing is to donate proton. So this proton will go and attack over here. So aniline will partially convert into anilinium ion. Remember that. Now what I'm saying, this is ortho para director. Aniline is OP director. Remember that it's being OP director. But this is meta director. And this reaction is given in your class 12th, that the product formed para is 51%, meta is 47%, and ortho is just 2%. Ortho is just 2%. 2%. Along with this, some tarry oxidation is also there. Anyways, I've told you each and everything, so let's see what should be the correct answer. Anilinium ion. This should be the correct answer. Do let me know. This should be the correct answer. Yes. Which of the following is aromatic? So this is sp3 hybridized, so non-planar. Can't be the answer. This is sp3, can't be the answer. This is sp3, can't be the. For aromaticity, two things are required, bare minimum. First thing, ring must be planar. And second thing, Huckel's rule. Am I right, kids? Am I right or not? So this one is following Huckel's rule 1, 2, 3, 4 and 5, 6. A planarity rule is follow, Huckel's rule is follow. So B should be the correct answer. Now this one, leave it. Yeah, this one is a really awesome question. Fantastic question, I would like to say. Will take some time. It's a time taking also, but do it. You will really enjoy this question. Let me check it out. Who is going to get the correct answer for this question, kids? Yes, kids. Everyone just do let me know what's the correct answer. Fast, kids, fast. Everyone C. Let me see whether C is the correct answer or not. This is toluene and bromine is coming over here. So first let's do the bromination. So it can't be the answer. It can't be the answer. Answer will be either from here or here. First do the bromination. 2 bromines will come. If you do the bromination, then this will decide. This will not decide because it is minus M. Can't decide. That is going to decide. Now once 2 bromines have been added over here, now it's your turn to remove this NO2. How to remove that NO2? By doing reduction, and then let's see what we can do. So Br2, this will do reduction and then hydrolysis. No, NH2 will come over there. Br2, iron, LiLH4. Iron reduction, if we do the reduction NH2, then ortho, yes. So these are not. So I'm sorry because they can't be the answer, this can't be the answer, and this can't be the answer. So if I react it with Fe, iron reduction will take place. So this is the wrong way. So first I have to go like this. If I do the reduction FeH plus, then this will get converted into NH2. And this is less ring activating because it is giving electron through plus H and it is giving through plus M. So it is going to decide its ortho is over here. Now if I do the bromination, so 2 bromines will come at this position. Now I will do diazotization. This HNO2 will do diazotization. It will convert into benzene diazonium chloride. Now this benzene diazonium chloride, now what they are doing? So even this can't be the wrong answer. That CuBr is saying that is wrong answer. This is wrong because CuBr will not do anything. H3PO2 will do reduction. So third is the correct answer. Third is the correct answer. That this will be go with phosphenic acid. So how great question it was. Get C. Even I have changed the answer. Really it was awesome question. Kids, do let me know. Do let me know this was really good question or not. Even I have gone through it twice or thrice. It was really Good question or not, kids? Do let me know. Everyone just do let me know. So it was, yeah, yes, Adhiram Roem. How many of you got it? Oh, you are still confused. Okay, let me tell you. Let me tell you how to solve it. Let me tell you. CH3NO2 is there, right? What they have done? Tin or iron HCl. This will affect NO2 and it will get converted into NH2 CH3. Now this is showing plus M because of lone pair. It will make its ortho and para conditions to be more electron rich through plus M, right? Or you can say plus R. So the incoming group will come and join this position, ortho with respect to NH2. Now our target is to remove this NH2. Earlier I have told you how to remove this NH2. Do diazotization. It will convert into benzene diazonium chloride. Now react with phosphinic acid H3PO2. Redox reaction. Now this will go away. Here is the answer. Now everyone understood. Do let me know in the chats. Do let me know in the chats. Everyone understood, kids. Show me green hearts if you really like the way I have explained, kids. Kids, Vishal MH, very good. Very good, Prajwal Reddy. Just 5 minutes more, kids. 5 minutes more to go. Harshpreet Singh, Chetan, Pathak, very good. Very good, very good. Next question is over here. Yes. Answer is already given. I have already told you. So, this is the explanation given over there. Here is another question. Wow, whatever. Fast. Vignesh Patel, very good. B. Some are going for B, some are going for C. Let me check it out. What should be the correct answer? The most stable carbocation for the following. Now see how to do it. This is plus charge and doing resonance plus charge will come over here. Then doing resonance plus charge. No support of this lone pair. No support. This plus charge will come over here. Will do resonance. Will come over here. No support. So this can't be the answer. Now the plus charge will come over here and the plus charge will come over here and it will get support of back bonding. So this should be the answer. And this plus charge, no. So answer will be C. C. Fourth one should be the answer, expected answer. Or D. The most stable carbocation for the following. No, that's wrong. A, B, third, D. Wrong answer. Gets This is the answer because it will get support. C is the correct answer. This is wrong answer, kids. Okay. Are you getting my point? Everyone agreed or not? Everyone agreed or not? Just to let me know in the chat. What I have told you, that should be the answer. C1 should be the answer, kids. First of all, do let me know in the chat. Agreed or not, kids? Do let me know, kids. Everyone agreed or not? Just 5 minutes more, kids. Agreed. Very good. Very good. Very good. D should be the answer. Yes. Now, next question. Here is another question. Ease of nucleophilic addition in the given compound. Remember that relative rate of reaction for NAR, nucleophilic addition reaction, directly proportional to magnitude of positive charge and inversely proportional to steric hindrance on carbonyl carbon. So if I talk about this is having positive charge and this is providing support of plus I, so charge is getting decreased, but here charge is getting decreased from both the side, so charge decreased more, and here the plus charge is stabilized by resonance. So this is going to be the least reactive. This is going to be the most reactive, kids. Most reactive, maximum reactive. So it should be 2, then 3, then 1. 2, 3, 1. So B should be the correct answer. So B should be the correct answer. Expected answer is B. Very good. Now here the geometrical isomerism is shown by, if I talk about this, 2 atoms are same, so can't show. Both are hydrogen, so they are same. And here this once again same, so can't show. Here these are same, so can't show. Only this one is left. This is different. These two are being different. And if you see, if you compare, it's CH2, it's CH2, but here CH3 is there. So this, if I say, is R1 and this is R2, so they are different. Will show. Means whenever there is double bond, so if this is R1, this should be R2. They should be different. If this is anything R3 or R4, they should be different. That is required. I hope everyone got it. 4D should be the correct answer. Yes. Which of the following reagent cannot be used for the given carbon? Nitro to aniline, tin HCl will do it. LiLH4 will do it. Palladium carbon iron HCl. Now what should be the correct answer? I think that should be the correct answer. Yeah, right? Because they all will do this. So already I have told you, either use tin HCl, iron HCl, any reactive element, palladium carbon, but LiLH4 will make it azo compound. Very good. Another. Oh yes, done and dusted, kids. How much you liked it, kids, do let me know. Really it was awesome. Really it was nice to meet you, kids. And it was really, I have enjoyed a lot because you kids responded very good, very well, kids. Bye to all of you. God bless you. Love you, kids. We'll meet you again in the next session. Do let me know in the chat section that really you enjoyed it. If yes, I want to see green hearts along with some fire, or red hearts, pink hearts, whatever the hearts you can give, kids. Bye to all of you. God bless you. Love you, kids. Bye-bye. Wow. Thanks for your love and support and this much of respect, kids. Right now, Baba HSP is taking this class from studio, and this is near about 27 kilometers away from my home. So I have to drive for 24 to 25 kilometers from here, then I will reach my home, kids. This is from my side because you kids are so awesome. You kids are loving your Baba, your Thalaiba, Wassim Sir, Ambika ma'am and Yava Sir. And you are always showing this much of respect towards this channel, kids. And this is because of all your love and support that I'm over here. Thank you, kids. Thank you. Bye-bye. Raji, Sunanda, thank you. Bye to all of you kids. Good night kids. Sigma boy, okay. Rupanshi, Sanju, Jion, Dr. Tharun, Yashwant Reddy, Afra. We will come with more sessions, and tomorrow I will put, already I made one recording of mind map. You will get mind map tomorrow, kids. Niveda, Ramesh Babu, Bhavya Shri, Shruti, Sashi, Akash, Athar, Fatima. We will thank you, Adhira Roem. And we will come with more sessions like this. Yashwant, thank you. Dr. Tarun, Chetan Patak, Jion, Lipstick Spoiler. Wow, what's her name? Fatima, Varsha, Priyansh, Dr. Purple. Wow. Sanju, good night. Kishore, Vishal, Priyansh, Bhavya, Ramesh, Adhira Roen. Bye kids. Bye. Bathiva, thank you. Vishal MH, thank you. Bhavya Shri, thank you. Rupanshi Kumari. Sanju, thank you. Fatima Khan, thank you. Varsha, good night. Rijwan Mabuzan, thank you. Radhika, I will let you know. No, Wasim sir will not come once again. It's over, kids. Class is over. Go and take sound sleep, kids. God bless you. Love you, kids. Okay? Whatever. Yes, whatever. Thank you. Thank you. Really, thanks. Chetan Patak, I'm good. Bye to all of you, kids. Bye-bye. Take care. And do proper revision, kids. Do proper revision. Bye to all of you, kids.